Welcome. We are coming to you from World Engineering Day 24 hours live. We're following the sun across all the global time zones on this World Engineering Day for Sustainable Development. From New Zealand to Costa Rica and everything in between, we will be live streaming all the amazing activities and events to celebrate the important work engineers are doing around the globe. Coming to you directly from Epicenter Studios, follow along for free on the World Engineering Day homepage. First up, Australia and New Zealand, with your host, Felicity Fury.
Engineering enables the development of societies and economies throughout human history and acts as an inexhaustible driving force for the progress of civilization. Engineering wonders are significant symbols of human history. The Industrial Revolution transformed our world from an agricultural economy into an industrial one. Every major breakthrough in engineering has significantly elevated productivity and profoundly improved human lives. Engineering facilitates fast travel and communication between hither to distant places. Therefore, we are all part of the global village. The World Federation of Engineering Organizations, or WFEO, was established in 1968 under the support and initiative of UNESCO. It brings together more than 30 million engineers from over 100 nations. For 50 years, WFEO has relentlessly promoted international engineering cooperation, a key force for the progress of the modern world. Nowadays, engineering innovations are developing rapidly. However, we're still facing global challenges such as energy shortage, environmental pollution, natural disaster, climate change, hunger and poverty, resources exhausting and diminishing of biodiversity. It is the mission responsibility of engineers around the world to address those challenges. Technological innovations are driving new industrial revolution. The progress and innovation of engineering will become an important means of progressing society and modern life. There will be a series of major innovations in such fields as energy, environment, materials, biology, agriculture, information and communication, manufacturing, construction, space utilization, and marine resources, transportation, social services. It lies in the hands of engineers to develop appropriate technologies and resources to promote the quality of the human lives and achieve a shared sustainable future. The World Federation of Engineering Organizations will continue its leadership and influence in the field of international engineering and make unrelenting efforts to build a better sustainable world for us all.
Engineering shaping sustainable future, a shared future of humankind.
Ladies and gentlemen, fellow engineers from around the world, today, March 4th, is a World Engineering Day for Sustainable Development. On behalf of the World Federation of Engineering Organizations, I would like to extend my heartiest greetings to all engineers in various fields throughout the world. The theme of this year's World Engineering Day is Build Back Wiser, Engineering the Future. At present, the international society is working collectively for Build Back Better. Better means not simply going back before the pandemic, but to learn from the pandemic and accelerate the transformation of sustainable development in the process. To this end, we need to build back wiser in order to build back better. Build Back Wiser calls for better leveraging the science, technology, and engineering to enable and accelerate the transformation, because science is the highest wisdom of the humankind. Engineers should better master science and technology, especially digital technologies such as big data, artificial intelligence, and Internet of Things, to innovate in various engineering fields, to benefit all people and leave no one behind. Build Back Wiser calls on more open collaborations. Open science is the historical trends of scientific, technological, and engineering development in every country, and is a requirement of sustainable development of the world. Therefore, to break down the barriers of disciplines, industries, and the national borders is of paramount importance for Build Back Wiser. Build Back Wiser calls for better assuming the ethical responsibilities of engineering. Engineers are responsible for ensuring the engineering solutions are of low and even zero carbon emission, meanwhile resilient and for the good of all people. Dear colleagues, today, on March 4th, the World Engineering Day, the World Federation of Engineering Organizations calls on all engineers across the world to join our hands together and March 4th for engineering a sustainable future.
Hello and welcome. My name is Felicity Fury and I am your host for World Engineering Day 24 Hours Live. I'm a civil engineer, senior lecturer at Swinburne University, and CEO and co-founder of We Aspire. I am so excited to be with you here in Sydney, kicking off our World Engineering Day celebrations. Today, we are meeting on the traditional lands of the Gadigal people of the Eora Nation. And as is tradition in Australia, I'd like to acknowledge the elders past, present, and emerging. The Indigenous and Torres Strait Islander people of Australia have some of the oldest engineering in the world. We can learn so much from their innovations, and I'm so proud to be Australian and be speaking to you from these lands today. We have an incredible 24 hours ahead of us, starting from New Zealand, Australia, heading all the way over to Costa Rica. We're going to be hearing from our hackathon finalists. We have 9 finalists to showcase with you today. We're going to be crossing live to hubs all around the world. None of this would be possible without the incredible team who've been working tirelessly behind the scenes over the last 8 months. And that is the incredible Mel and Tennille, who you'll be meeting later today. And of course, the World Federation of Engineering Organizations is behind this incredible day. And they've done a fabulous job at helping put all of this together. Now, to kick off today, we are joined live in the studio by the incredible Marlene Kanga. She is personally one of my favourite engineers, someone that I take real inspiration from. She's the immediate past president of WFEO and was leading the proposal to get this day happening. So none of this would have been possible without her. She actually just told me before we went live there was 5 trips to Paris, getting 40 countries to sign up to make this day happen. So it's been an incredible effort, Marlene. So Marlene, what does this day mean to you?
Well, thank you, Felicity. It's an incredible honor to be here today, and I'm so excited, firstly, with the celebrations that are planned around the world, not just the 24 hours, but all our members and partners celebrating World Engineering Day on 4th March. And that is what this day is all about. It's our day, it's your day. We hope you'll have a wonderful time celebrating engineers and engineering around the world, and most importantly, engaging with the community, with parents, with mums and dads, and with young people, boys and girls, and tell them what a wonderful career they could have as engineers, because the world does need more engineers and lots of engineering.
Absolutely, completely agree. As an engineer, I think it's so important to celebrate this day. Why do you think it's important that we do celebrate not just World Engineering Day, but World Engineering Day for Sustainable Development?
Yes, thank you, Felicity. That's a very good question. As engineers, we tend to do the technical work very well. We tend to just put our heads down and get on with it. And we leave the talking to other people. But I think it's very important that we do talk about our work and the impact that it has on the world, on modern society. And as engineers, we are the change makers. We actually have the skills to make things happen. In terms of climate change, the transition to a low carbon economy, it is engineers that are going to design and develop and implement the solutions. The policymakers will talk about it and make policies. The financiers will fund it, but it's the engineers that will actually make it happen. And this is the day that we need to communicate this very important message, that we can't make the changes that are so important and desperately needed around the world without engineering and engineers.
I think that's the best thing about being an engineer, is that I get to go out in the world and say, I made that happen. And you can see the impact that engineers get to have every day. And there's also a lot of unseen stuff behind the scenes that we do that makes the world work. So from a World Federation of Engineering Organizations perspective, what work do we need to do in this region?
Well, I think we have some serious issues, especially in relation to climate change. And I'm so glad that Engineers Australia, which is the national member of the World Federation of Engineering Organizations, is addressing this issue, as is Engineering New Zealand, another national member, and we have other members in the Pacific region. Of course, our Pacific neighbors are affected by climate change, by natural disasters, by with the recent eruption and tsunami, volcanic eruption and tsunami that was experienced in January. And so there's a lot of engineering work to be done. Basically, we need more engineers in these regions, in developing countries, and we need engineers with the right skills so that these engineers can work on projects in their own country, design, construct, and maintain them. So we need to teach people to fish so that we have a sustainable society. This is the important work that the Federation needs to do in our region.
So important, and I think you touched a great point around what the future is going to look like. We're in really uncertain times, obviously the last 2 years with COVID. I've flown down from Queensland. We've been having a lot of flooding in the area, and it's happening all across Australia right now. So what do you see is the future of engineering? Is it addressing some of these challenges, or is it kind of thinking beyond kind of those problems that we're facing and thinking bigger picture?
Well, engineering really needs to change, to transform, to meet the challenges of tomorrow. I think we have established this profession about 100 years ago, and it was very male-dominated and had a certain culture which still prevails in many countries. So first of all, to address the shortage of engineers around the world, we need to tap into the 50% of the brain power that is of women and encourage more women to consider engineering as a career, and to change the culture of engineering to make it more inclusive, to support engineers of all origins, all ethnicities, all ages, because we can all make a contribution. We also need to change engineering in terms of the skills that engineers have in dealing not just with the technical issues, but also with the impact of their work on society, on the environment, on their communities, and to be able to engage with people to talk about the work and the impact that it can have. I think a lot of engineers don't have these communication skills. Being able to work in teams, including remote teams, as that's become more common as a result of COVID, is also important. And I'm so glad that the World Federation of Engineering Organizations, under my leadership, reviewed the engineering education benchmarks, which are governed by the International Engineering Alliance. We formed a partnership project in late 2019, and we delivered the new benchmarks that were approved by the International Engineering Alliance in June 2021. And these have been translated into 6 UNESCO languages so that everyone can get access to them. And these benchmarks are one of the platforms that will make the change that engineering needs for the future.
Absolutely. It's so important, that education piece, and not just for people coming into the profession, but people who are already in it. So that's such a great resource that everyone can tap into and use. We're going to be hearing a little bit more about that later today. There's so many engineers that are hopefully watching. Marlene, have you got any messages for people who are engineers right now? What can we do to create a more sustainable world? What message would you have?
Well, I think, as I said, we engineers can make it happen. So just do it. We've got the skills. So just, don't be afraid to tackle the problem, because we are incredibly innovative. We come up with great ideas, and we certainly know how to work out how to make it happen. So my message is just do it.
I love that. Just do it, be brave, take charge. An awesome message. Thank you so much, Marlene. It's amazing to have you here live in the studio. We are now going to hear a message from our sponsors who are helping us with transcription and transcribing today, so you can hear this whole 24 hours in 6 languages. So over to our sponsor.
科大讯飞作为亚太地区最大的语音技术及人工智能上市公司，是中国语音产业唯一的国家规划布局内重点软件企业。成立至今，先后2次荣获国家科技进步奖、智能语音识别、语种识别技术，名列世界前茅。2015年12月21日，科大讯飞在年度发布会上推出了全球首款会议字音同步直播产品讯飞听见。讯飞听见智能会议系统可以将语音实时转写成文字，同时实现中英文互译，中文转写准确率可达95%以上，英文转写准确率可达90%以上。同时采用独立部署的专业服务器，可实现音视频文件离线转写。更有中英多语种操作版面，支持英文识别、中英文实时互译等多语种识别翻译功能。为满足媒体行业用户的差异化需求，讯飞听见还推出了听见智能文稿唱词系统，它集音视频转唱词、音视频转文稿、文本翻译功能于一体，支持实时、离线转写2种方式，通过文本和画面智能同步，轻松完成字幕制作。在录音整理过程中，通过智能角色分离、音频文稿联动编辑的功能，快速编辑音频素材，帮助媒体工作者提高工作效率。针对个人用户，讯飞听见推出了专业的语音及文字综合服务平台讯飞听见网站与听见 APP， 通过机器快转与人机精转2种方式，提供音频转文字及翻译服务，可以直接上传已有录音，快速收到文本结果。如果您是企业用户或开发者，讯飞听见还提供录音文件识别、实时语音识别、翻译等多种能力授权，通过接口的方式输出中文、英文等多语种的转写、翻译等服务。成立至今，讯飞听见致力解决智能语音技术在政府办公、企业音频价值挖掘、媒体节目制作、日常录音整理等多方面实际应用问题。讯飞听见将继续秉承讯飞精神，立足全局，纵深发展， 带您开启智能高效知识管理的新时代。
Thank you to our sponsors. If you would like transcription, you can head to worldengineeringday.net and find 6 different languages that you'll be able to hear the next 24 hours live in. We are now crossing live to our first location right here in Sydney, Australia, which is the University of New South Wales. Let's check out what they are up to.
It's really great. I love all the society.
It's a new experience for me.
You just make a lot of friends in a really quick amount of time.
Our week's been amazing. Yeah, you get to meet a lot of people. It's a great vibe. Like music's going on, everyone's like enjoying themselves. We'll see you on campus at UNSW.
Hey everyone, my name's Chris. Welcome to World Engineering Day. We're just going to talk to Richard Hopkins and then Benjamin Heiner about the SunSwift project here at UNSW. We'll jump to them now. What is the SunSwift project?
SunSwift Racing is a student-based project here at UNSW. Been around since 1996, so going into its 26th year. Over the years, it's changed its model slightly. It was formed out of the electrical school back in '96, very much run by academics and PhD students. And over the years, it went towards an undergraduate student model, which is largely what it is today. But 2 years ago, significantly, we put the project into the curriculum. And that's where things changed. And fortunately, we've really been able to grow the project as a result, become more credible, maybe as a result. And certainly when it comes to industry engagement, we've attracted a lot more technical partners to help the team. And we are a team of undergraduate students with some PhD students as well, which is absolutely fantastic, and they bring a lot of experience into the team. The team, they design, build and compete a from scratch solar electric prototype car, just like the one you see behind me. Once upon a time for the team, the primary focus was of course the Bridgestone World Solar Challenge, which is the biannual event that runs from Darwin down to Adelaide. It's the World Solar Challenge. Over those years of competing, the team's been hugely successful, and only back in 2019, the team on the road finished first, second overall. Unfortunately, last year the 2021 race, due to COVID, was cancelled. That was quite a significant moment for the team, because we all realised that maybe there are other things that the team could be successful at, other goals and other focuses, rather than just this one event. SunSwift Racing is a solar electric racing team, and we are certainly pushing the boundaries of all of the technology that we get across. Things are moving on quite significantly at a very rapid rate across the world, with governments pushing zero emissions and convincing everybody that EV ownership is the way forward. And indeed it is. It will certainly reduce the carbon emissions globally quite significantly. It may not be the only solution out there, and certainly at SunSwift we're going to be exploring lots of other options and combining other technologies. SunSwift in 2022 will be opening the door and exploring the options of hydrogen power. That indeed has its challenges. Certainly packaging inside a vehicle of this size may be more appropriate at the moment with larger scale vehicles, heavy goods vehicles, trains and boats, etc. But I think we see that certainly as a challenge of combining hydrogen fuel cell technology and solar and electric together and seeing what we can do. Here at SunSwift Racing, we have a bit of a philosophy of certainly allowing the students involved to be exposed to all the advanced technologies that exist, and hopefully some that don't exist yet, and they can take some responsibility for discovering what those might be. We've spoken about the solar energy, we've spoken about the battery electric power, but also we have a strong focus on advanced manufacturing and the materials that are used within the construction of the chassis and all the other components on the car. We use composites extensively and 3D generative design as well. The uprights on the car are aluminium 3D generative design. The suspension is composite as well. So there's a lot of composite technology here, lightweight, strong, which certainly when we're looking for efficiency, that's very important in reducing the weight and the strength of the car. I think the whole nature of automotive design is going through a fairly huge paradigm shift from what was old. I think the interpretation of performance has changed, certainly from when I was a kid. And I used to look through automotive magazines, and my idea of performance was speed and power. Today, it's not. It's safety and it's efficiency. And as a result, to gain that greater efficiency, weight of cars has certainly become an important part. And if we can reduce the weight of cars, that will increase the efficiency. If we use these advanced materials to reduce the weight, we also increase the strength. So we're also having an effect on the safety of cars as well, which is key and important to realize. The solar technology that we currently have today gives us great advantage. But certainly alone as a technology, it's not currently in a place where we can rely on it all by itself. But certainly it will enhance the energy generated by a vehicle going forward. So I certainly see a transition from pure EV to some form of solar incorporation within cars in the coming years. Funny, you know, the Bridgestone World Solar Challenge started in the early 80s. I think when people saw solar cars back then, it was very much seen as the Jetsons, and it was really way off into the future. But that future is here with us now, and we do see car manufacturers certainly entertaining the idea of incorporating solar into their vehicles. Maybe not purely to power the vehicle, but certainly maybe to help some of the onboard systems. But as the technology increases and the power increases, the efficiency increases, I think we'll see solar playing more of a part going forward. And certainly being responsible for powering maybe not long distances, but maybe commuter journeys for sure. Sunswift Racing is on a bit of a journey. It has been for 25 years, but I think certainly over the last couple of years we've put much more focus on what we're going to be doing tomorrow and the next day and in the years to come. Certainly for us, we see ourselves at the beginning of that journey, and certainly with the students' involvement, the idea is that we certainly give the students a far greater experience and exposure to all the emerging technologies that are around us. And that in turn is an advantage for the project itself, because the project will benefit from all of those approaches. I think going forward, we would like to play more of a significant part in productionisation of these types of vehicles. Who knows, Sunswift Racing might start making its own production vehicles in the years to come. But certainly if we can help and start influencing technology in a broader spectrum, that's certainly what we want to do.
My name is Ben, I'm the Chief Designer at Sunswift Racing, and I've been on the team for about 2 years, so the entire build cycle for Sunswift 7, and I was mostly involved with the aerodynamics, exterior design, and then into chassis design and construction. For us, we mostly use carbon fibers and fiberglass, so those are fiber-based composites. A composite is basically any combination of two or more materials that are put together to make the most out of the differing material properties, and they generally have like a fiber and a matrix, and the matrix is usually made up of like a resin, like an epoxy or a vinyl ester resin. the fibers themselves are really strong in tension. So depending on the orientation of those fibers, we can get different material properties, different stiffnesses out of the same shaped part. And that's been really helpful for us, where we might require some local stiffness or local reinforcement on the car. We can achieve that pure Bulgarian fiber orientation rather than necessarily adding lots of material that would then add a lot of weight as well. With those anisotropic properties, we can overall achieve a really lightweight but high-performing part that you wouldn't else be able to achieve with something like an aluminium or a steel-based component. A wet layup is basically taking dry carbon fiber cloth. It comes in a roll and you just cut it to size and you lay it into the mold while it's dry, and then you use a resin, like for us epoxy, and you wet it out afterwards layer by layer. So you put one layer into mold, wet it out, put the next layer on, wet it out, make sure everything's nice compressed, and then at the end you vacuum bag the whole assembly, put pressure onto the mold but also pull out any excess air. Whereas a pre-preg layer basically comes on a roll with the epoxy out of the freezer, so the epoxy hasn't gone off yet, and it allows you to, one, be a lot more accurate when you cut it. It's a lot less messy. You sort of just cut little pieces of sort of dry feeling carbon, you lay that into the mold and then you cook it to get the epoxy to cure. Whereas wet layup, you don't necessarily have to cook. Wet layup doesn't involve the whole cooking process, the curing process, so that cuts a bit of time out of it. And it also allowed us to use cheaper molds, especially the sort of purple CNC foam that we used. When we did use that foam on one pre-preg part, which is the roof of the car, we noticed that possibly the porosity in the foam actually didn't handle the heat change during the curing process. So wet layup was cheaper and faster for us and allowed us to use cheaper, easier molds. Largely driven by aerodynamics, but setting out constraints, like for example, the interior cabin size became a constraint, where if the aerodynamics constantly wants to make the car smaller and moving inwards, the interior is sort of going the other way. And similar with suspension design, steering, motor positioning, packaging of possibly storage space, those all become constraints that you design around. And the way I went about my aerodynamics was I sort of had those regions blocked out in CAD and almost molded the car around it. And then anytime I made an aerodynamic iteration, I made sure that I wasn't intruding on interior space, suspension, geometry. But the aerodynamics took a very heavy priority over things like interior, which is why the car isn't necessarily the most comfortable. It's quite common, like you mentioned, to see the sort of catamaran style with that cut out through the underbody of the car. Part of the reason you do that is because you reduce the frontal area of the car. So the overall resistance to air, the drag, is made up of the coefficient of drag, which is an aerodynamic parameter, and multiplied by the frontal area of the car, which is essentially just the projection of the car in its driving plane. And reducing frontal area is a really easy and effective way of reducing the overall air resistance, the overall drag force on the car. So if you can cut something out of the underbody, that's like taking a little chunk out of the frontal area. So that's one benefit. The second benefit is that in that cutout, you locally increase the ride height of the car, which generally allows the pressure to balance out in the underbody. Whereas if you had a flat underbody that's close to the ground, you're going to get a lot of low pressure in that underbody, and that low pressure is going to create downforce, and it's often going to create drag as well. And while downforce is definitely favourable in a race car or like a traditional race car, solar cars kind of want to avoid generating downforce because it generates rolling resistance as well, and obviously want to avoid generating drag. So the more consistent that pressure is for the underbody, the better. This iteration, Sunswift 7, still has that cutout. It's a lot less defined as it was in Violet or other solar cars. And the reason for that is because I found other ways of reducing the drag and balancing the pressure. But it's definitely still there, and it's definitely still is that it's still favourable to try and raise the underbody but keep it all sealed off. So you still you get that boat-like catamaran look to it, and even when the underbody came from mold, people still thought it was a boat, and people didn't realise it was a car for quite a while. I think the low drag approach is definitely going to carry over into commercial applications, and I mean it is already. You start seeing like a new Mercedes, their brand new electric concept has a really low drag. That low drag approach, and especially in the underbody, is something that definitely carries over to electric vehicles. I don't think we're going to see normal pedestrian, like the typical sedan or typical hatchback. I don't think they're going to take that same extreme approach where they really favour aerodynamics over everything, because normal cars have different requirements with interior. But the sort of mindset and the philosophy behind creating something that's really efficient while still having a defined design language and still looking nice, that's definitely going to carry over, and it's starting to already. At the moment, it's probably quite difficult to mass produce composites as well. At least the way we manufactured them, it was all hand layup really, and that becomes quite time consuming and expensive compared to the normal production line of a car. But with new methods coming up like the AFP robot at uni, or sort of the Industry 4.0 approach, you might be able to see a lot more composite manufacture coming into full-scale production. That was an interesting process actually. It's something that I hadn't done before in the past, and we mostly relied on simulations, as we don't have a wind tunnel, or we didn't have access to a wind tunnel where we could have had iterative development that way. We had to rely on simulations, and the software that I used was ANSYS, and within ANSYS something called Fluent, and that allowed me to essentially simulate the airflow over the car as if the car was just driving down the highway. Things like pressure changes, drag, lift, all those values that you're interested in when you're trying to optimize the aerodynamics. And once I have an initial iteration of the CAD model, I'd run the simulation, I would look at the results, and then I'd change the CAD model again. And all of that process was manual. And I then went on and did that 57 times to achieve a final drag value, or coefficient of drag, of just under 0.09. Which, for comparison, the most efficient road car at the moment will be probably Lucid Air at 0.2, so we're less than half that. And the frontal area of the car is about 1.86 meters squared, so ballpark 0.17 coefficient of drag times area, which is quite impressive, and it took a lot of effort to get to that point. But again, a solar car has different requirements, or our car had different requirements to a normal road car, so they're not completely comparable. And I realised there's a lot of potential to improve there. So I went on afterwards in my studies to try and optimise it, and found some ways to use adjoint solver methods to automate some of that process, where the software itself starts looking at the geometry and which areas of the geometry were generating more drag than others. So finding the sensitivity of a surface to a change, and how that affects, in this case, drag. And managed to get a further 80% reduction fully automated without me making any CAD changes. So that automated side of development is probably going to have quite a bit of impact moving forward. But I think the manual side of it, and even wind tunnels, are still going to remain, because it takes a bit of that, I guess, human experience to make sure that the changes being made are actually realistic and still within the design language of the car.
Alrighty, so it was really good to hear from Ben just there, and Richard. Thanks for that, guys. We'll jump back to you in the studio. Over to you.
Thank you, University of New South Wales. That was awesome to see what you've been up to. How cool that you've been able to create that solar-powered car. I know that's something I'd love to be able to drive around Sydney, and hopefully that's what we get to do in the future. Super cool. We're going to be hearing more from the University of New South Wales later. Now, throughout the day, we have got a hashtag going, hashtag World Engineering Day. And over the next 24 hours, we're going to be featuring all of you live tweeting, getting out on social media, and sharing all of the celebrations around the world. So if you're celebrating World Engineering Day or you'd like to share about your engineering awesomeness, get onto the hashtag World Engineering Day, and you may even find yourself live on our 24-hour program. Next up, we have a message from Professor Hugh Bradlow on World Engineering Day. He's the president of the Australian Academy of Technology and Engineering. Let's hear from Hugh.
I'm Hugh Bradlow, President of the Australian Academy of Technology and Engineering. The Academy is delighted to support the World Engineering Day for Sustainable Development. Engineering is at the heart of the modern world, and engineers are creating the future that will allow 10 billion of us to share this planet without destroying it. The Academy has approximately 900 fellows who are leaders in their fields of technological sciences and engineering, and are working on a wide range of critical topics. To give you just 3 examples, we have fellows who are building quantum computers that will solve a range of problems, such as the design of new materials and drugs. Others are looking at ways to economically recycle waste products that would otherwise end up in landfill or polluting our oceans. And then there are those that are addressing our need to provide clean water in remote communities in a sustainable and economic manner. These are just 3 examples, but are amongst many in the Academy, which is bringing the brightest minds to bear on the sustainable development of Australia and the world.
This year for World Engineering Day, we launched the hackathon. Each year, World Engineering Day is getting bigger and better. This hackathon was aimed at university students. So we're going to deep dive into what this hackathon is before we share some of the finalists with you. We're going to be showing all 9 finalists over the next 24 hours. Now, this challenge has been incredibly important to address some of the sustainable development goals. And so I'm going to make sure I cover everything off with you and refer to some of my notes as we deep dive into this. A huge thank you for everyone who dedicated their time to making this happen. It's been an incredible effort from many, many people. We were overwhelmed with over 1,000 people registering their interest for this challenge, and it's been an incredible response from all around the world. We're going to be announcing the winner live in Costa Rica, so stay tuned for that tomorrow if you're in Australia or wherever you are in your time zone around the world. So there's 3 challenges for our hackathon. The first hackathon was responsible and innovative use of materials and reduction of non-biodegradable waste. This is an engineering challenge that involves responsible use of materials and innovations that will ensure that the materials can be recycled and reused. This challenge was to develop a product solution that addresses the resource challenge, or a system to recover and reuse materials. You might start by considering the questions: what waste streams are you familiar with, or can you see impacting in your local community? What scientific knowledge could you use to tackle this problem? And how could you meet the requirements of easy to use, economically affordable, safe, and environmentally friendly solutions? So that's challenge 1. Challenge 2 is focused on biomimicry in engineering solutions. And I think biomimicry is such an exciting way to solve problems. In this challenge, it was focused on learning from nature for sustainable solutions that result in innovation, optimal resource use, and healthy, improved living. This is an engineering challenge that looks to nature. for inspiration and solutions for sustainable engineering challenges. The challenge is to develop a product or system that addresses sustainable use of materials, reduces energy and water consumption, uses a resilient approach to natural disasters. The project brief is to look to nature for inspiration and propose an engineering solution that will result in increased performance in sustainability and human well-being indicators. The challenge is not limited to buildings or any other type of product, but it could be for any technology. Nature can be the source of many innovations and inspire engineers to develop products and ideas that are innovative and sustainable and reduce energy and resources that are consistent with World Engineering Day for Sustainable Development. Challenge number 3, climate-resistant water management systems to ensure safe and ongoing access for all. This is an engineering challenge for the responsible use of water in our cities, towns, and villages across the world. Solutions can be for clean water or sanitation and other responsible uses of water, including solutions and systems for recycling. The challenge is to develop a product or system that addresses sustainable use of water for clean, healthy, smart living and is consistent with the theme of World Engineering Day for 2022 to build back wiser. Engineering the future. So we have 3 incredible challenges for our hackathon, and we're about to hear from our very first finalist. We're going to be crossing live to the wonderful Nankai University to hear from Team 466 on how they address this hackathon challenge.
Hi, I'm Jiale.
Hi, my name is Fang Yu.
Hi, you can call me Wen.
Hi, I'm Zijie.
And we are Team 466.
And we are really honored to have been selected as a finalist in World Engineering Day Hackathon in 2022. And please enjoy our entry on Intelligent Water Quality Monitoring System.
Lake Victoria, the world's largest tropic lake at 26,560 square miles, which provides drinking water for about 30 million farmers, besides environmental problems of invasive water, hyacinth, and hippogras. Climate change is expected to exacerbate water quality degradation as a result of higher water temperatures and thus a reduced self-purifying capacity of freshwater bodies. Shared by Kenya, Tanzania, and Uganda, the transboundary character renders the water climate adaptation action to Lake Victoria more problematic. Working towards climate-resilient lake management, especially to improve delivery of accurate and timely water information, our team has developed an IoT-based 3-layered intelligent real-time water quality monitoring system. The first layer is data collection. The fundamental principle is that optical active constituents in water such as chlorophyll, colored dissolved organic matter, etc., will directly affect the spectral characteristics, while some light-intensive substances such as nitrogen and phosphorus can be estimated by combining optical signals with complex model algorithms. Drawing on the principle of analytical spectral devices, the instrument realizes the continuous fixed point real-time data collection. We can directly estimate data of chlorophyll A, total phosphorus, total nitrogen, dissolved organic carbon, and particulate organic carbon, which cannot be measured on site but in lab. The second layer is data transmission. On top of this, the narrowband Internet of Things technology is used to transmit the optical data to the cloud server in real time. Preparing for future processing, it enjoys the virtue of wide coverage, massive connection, low power consumption, and well supports the entire system's data transmission in low cost. The third layer is data application. Machine learning algorithms helps to fulfill the data intelligent calculation and modeling. It results in a cloud platform on the computer terminal, on which the real-time and historical data information are visualized, making it possible for decision makers to check on them remotely, locate monitoring points, and predict on the future data fluctuation. Commonly applied sensor-based water quality monitoring provides merely preliminary observational data. Satellite imagery approach requires sophisticated technical acquisition, processing, and algorithm application. To improve on, we apply 3 detectors to measure skylight, water surface, and total radiation respectively, so as to accurately obtain the water surface reflectance, radiance, and radiance in a specific spectral range in real time. The original spectral data are thus converted into the water quality nutrient parameters. With this approach, we can directly estimate data which cannot be measured on site but in lab. The first and foremost consideration to promote our project is the transboundary national management of the lake. The system allows data transmission in any country since it supports MBLOT and runs based on computer software. For other lakes, especially in less developed countries, we plan to use algorithms constructed by water body data of similar type. Naturally, the algorithm optimism becomes the main challenge in the future. Here is the estimated cost. Water-related ecosystems such as lakes are among the world's most biologically diverse environments and provide multiple benefits and services to society, making them essential for reaching Sustainable Development Goal 6, the water goal, we attempt to advance, specifically the delivery of the target 6.6, which aims at protecting and restoring water-related ecosystems. We believe that to help build that wiser, engineering in post-COVID period highlights more than ever on a such broader interdisciplinary and complex problem-solving approach and the transnational collaborations.
Wow, how incredible was that first finalist? The judges must have had such a difficult job choosing the finalists from over 125 entries from 23 countries. We are now going to hear from our second finalist, which is Team Gratz from the University of British Columbia, Okanagan campus in Canada. Let's hear from our second finalist.
Hi, I'm Paul.
Hi, I'm Ryan.
I'm Angela.
Hi, I'm Farid.
And we are Team Gratz.
We are very honored to have been selected as a finalist in the World Engineering Day Hackathon in 2022.
Please enjoy our entry about the fog harvesting systems designed for Namibia.
Hi, my name is Johannes Thomas. I am from Omutsokonime village in northern Namibia. I'm going to talk about the water problems we face due to climate change. This is a pond. I know it doesn't look like it because of all the grass. Usually around this time of the year, the pond should be full of water. It barely has any water. We use the water from the pond for household purposes, and the livestock also drink water from it. So it's a source of life for the humans and the animals, but there's barely any water in it.
Namibia has heavily relied on water reusable projects. However, with the decreasing rate of rainfall and receiving less than 50% of the expected rainfall, this causes extreme pressures on the available water resource projects, which are unable to deliver the water necessities in Namibia. This results in the government declaring a national state of emergency frequently. The fog harvester consists of a silk mesh net that is faced towards the fog and the wind. The mesh net collects water droplets which will be displaced into a tube where it will go through filtering to separate the sand and dirt particles from the water.
The filter will be attached to the fog harvester and filter any water collected from it. Since the fog harvester will be used in the Namib Desert, any sand particles collected alongside the water will be filtered out and ensure that only potable water is produced. After the filter targets larger particles such as sand, a pH solution will then be added to the water to ensure that the water is safe for human use and consumption.
Locally sourced from Namibia, Kalahari wild silk has been researched to be a part of a family of hydrophilic glue-like proteins. This silk has a wide variety of uses in Namibia, thus making it the perfect material to use for mesh netting. Its hydrophilic abilities will allow water droplets to attach to the material and is efficient in water collecting.
Since the temperature in the desert is extremely high, the collected water could potentially evaporate. Therefore, storing water in the underground sand dunes would minimize the outcomes due to the low thermal conductivity of sand. Measurements such as adjusting the pH using non-corrosive pipes, filters, safe storage facilities, as well as disinfection, allow us to comply with the water standards given by the World Health Organization and the Namibian government. The fog harvester is a completely passive system, and compared to other atmospheric water collectors, the biggest advantage the fog harvester holds is it requires zero energy. Moreover, the fog harps do not interfere with the environment or the animals at the Namib Desert.
Our device aims to achieve Goal 6 of the Sustainable Development Goals. Specifically, we aim to achieve Goal 6.4 as this technology can substantially increase water use efficiency to address water scarcity. We hope that by introducing our technology to areas with similar struggles and conditions of Namibia, Goal 6.4 is able to be met by 2030. Here's a simple representative prototype of our fog harvester. We built the fog harvester in order for it to be easily assembled and disassembled due to previous fog harvesters failing as they had complex maintenance and the need for external supervision. If one part of our fog harvester was to break, we can easily replace that with another part, thus making it all brand new again. Anyone can build this fog harvester, so eliminates the need for minimum maintenance. In the next part of the video, I'll be showing you in 4 easy steps on how to build one. Step 1. Connect the water collector to the poles. Step 2. Place both the water collector and the poles in the ground, or in this case, the sand. Step 3. Slide in the net material into the poles. Step 4. Connect the tubing to the filter, which is attached to the water collector. While the fog harvester is at work, let's discuss the implementation of the device. Investing in fog harvesters that have 40 meter square nets would create an additional water source for Namibia, with each net costing around $1,000 to $15,000, and they can last up to 10 years. After a few hours, our fog harvester accumulated around half a cup of water, and now the additional step is to drink it.
The fog harvester has the immense potential to increase access to water in Namibia and reduce water emergency-related issues.
Namibia has struggled with food security due to the country being water stressed, and by providing an alternative water resource, this could also help stabilize food security and livestock.
With the stabilization of the agriculture, there is the potential for the creation of additional jobs, creating a boost in Namibian economy.
We hope that the fog harvester will help the people of Namibia and alleviate the water issues they face.
Wow, that was incredible work, Team Grads. You're solving a really important challenge. We are now going to hear from our next finalist coming in from India. We have Team Hafitas from Hyderabad Institute of Technology and Management, India. Over to you.
Hello everyone, I am Nanisha.
Hi everyone, I am Hirakita.
Hello everyone, this is K. Deeptishri Reddy.
Hello everyone, this is Neha. Hi, this is Pauli.
We are from Team Hephaestus, Hyderabad Institute of Technology and Management, India.
We are very honored and feeling excited to have been selected as a finalist in World's Engineering Day Hackathon 2022.
Please enjoy our entry about OctoCleaner.
OctoCleaner is an underwater robot which cleans waste like plastic and also the sedimentation which is deep inside the water bodies. Thank you.
Rainfall and agricultural runoff contain not only water but also trash such as plastic, leaves and muck. This pollutes rivers and lakes, causing sedimentation and pollution. Sedimentation occurs when garbage and muck collect at the bottom of rivers, reducing the water capacity of rivers and lakes over time. It can't hold a lot of water. As a result, floods occur. floods can occur even in fewer rains. It's one of the factors that contribute to flooding. The waste also pollutes the water supply, and plastic inside water bodies is a major cause of water pollution. Fish, seabirds, turtles, and other aquatic animals can become entangled in or ingest plastic debris, causing suffocation, starvation, and drowning. If one plastic bag can bring down birds and fish, imagine the consequences of this number. The effects of plastic on marine life are so devastating. Soon the planet's sea animals and birds will end up as nothing but statistics. Species will slowly become endangered and then extinct. Our proposed solution is Octa Cleaner. It is an underwater robot that can go deep into the water and collect trash from within. It works using 3 major parts: gripping hand, conveyor belt, and propellers. The gripping hand is used to collect waste. After collecting it, place the waste on the conveyor belt. The conveyor belt throws the waste into the net. Propellers are controllers using transmitter and receiver. It is used for the upward and downward motion of the robot. Due to the short span of time, we have made a mini prototype of our idea. Our future steps are we will add machine learning technology and sonar technology to detect plastic and other waste. We also include mechanisms to remove sedimentation. We also include flapping and gripping techniques of fish and octopuses. We intend to use this robot in the oceans as well. Once we have the necessary resources and funding, we will periodically update it with the most recent technology. We also include a mechanism to collect muck. We are inspired by biomimicry and engineering. We took aquatic animals as inspiration.
Imagine a world without standards, a world built without order, guidelines, or safety procedures to protect us and move our economy forward. Buildings would not stand the test of time. Safe access to power, water, and digital communication would not exist. Standards Australia has improved the quality of life for the past 100 years. Since 1922, Standards Australia has been developing and adopting guidelines that drive Australia forward. From our first committee designing the bolts that keep the harbour bridge together, to the creation of the wiring rules, which remains the most used Australian standard of the 21st century. In 1925, Standards Australia extended its sights beyond our borders and joined the International Electrotechnical Commission. And in 1947, we helped establish the International Organisation for Standardisation. We remain active members of both bodies today. In 1988, Standards Australia was recognised as the peak non-government standards development organisation. In 1997, we were one of the first organisations worldwide to deliver standards publications on the internet. Today, Standards Australia has over 28,500 standards and technical publications, is a world leader in the development of the critical emerging technology standards, and is an international collaborator with other leading standards organisations, creating a safe and sustainable environment both at home and abroad. There are few organisations that have made such an essential contribution to the quality of life while leaving so few footprints in public awareness. Looking forward, we want to continue to empower communities and be a trusted global leader in solutions that improve life, to facilitate standards development to meet the needs of a fast-moving society, to provide easier access, and to deliver critical projects that strategically or economically promote Australia.
The solutions that Standards Australia has developed over the past 100 years have benefited each and every Australian. Our work has never been more important. join me in thanking our contributors, industry partners, members and staff who have built this valuable national asset. I warmly welcome you to celebrate with us in our centenary year. This year, Standards Australia is supporting engineers and the work they do by sponsoring World Engineering Day. Engineers help build a safe, innovative and sustainable world and are active contributors to the development of many important standards. For 100 years, Standards Australia has worked alongside engineers and other specialists to provide practical solutions for all Australians. We look forward to our connected future with excitement and anticipation and working with the engineers of today and tomorrow.
All engineers have a role to play to ensure the UN's Sustainable Development Goals are achievable. As an engineer myself, I'm delighted to celebrate this internationally recognised day. From all of us at Standards Australia, we celebrate with you. Happy World Engineering Day.
Thank you, Standards Australia, for celebrating World Engineering Day with us. I have no idea what our world would be like without you. I'd also like to thank our platinum sponsor for the hackathon, Intel, who we'll be hearing more from later. We are now crossing back live to the University of New South Wales to hear more about their exciting engineering projects. Over to you, University of New South Wales.
Welcome back. So we're back again with the SunSwift Racing project here at UNSW, celebrating World Engineering Day. We'll now jump to Alexander Eyre, who's going to talk about some of the suspension and wheel design on the car. And then we'll jump to Tom Killingback, who will talk about some of the telemetry systems. So over to them now.
Hi, I'm Alex. I'm a Chief Engineer with SunSwift Racing. I've been in the team for just short of 2 years throughout the design development of SunSwift 7, and I'm currently pursuing a PhD with the AMEC Centre at UNSW. Professor Gaynor Frosty is in charge of the AMEC Centre.
This is AMEC. I'm Ganga Prusty, the Director of the Training Centre. This is an ARC-funded training centre on solving advanced composite challenges. Here is an example. We are developing a novel adaptive composite propeller using advanced composites.
Traditionally, composites are manufactured using a lot of labour-intensive methods, which have high costs and take a long time to produce components. So a key new method that's emerging is called automated fibre placement, or AFP, and this involves basically a robot arm with a very complicated tape dispenser on the end, and it can lay up carbon fibre material in all sorts of complex and varied geometries to automate the process and reduce manufacturing defects, but also helps with consistency between components. Currently I'm working on a project with automated fibre placement that involves the design and manufacturing of a carbon fibre wheel. So wheels are a really interesting area for lightweighting because they contribute not only mass to the car but also rotating inertia, which is really key to be reduced. Traditionally, composite wheels have to be made by hand because of the complex shapes. So the shape of the spokes and the rim itself, which has kept the price of them reasonably high. So we're interested in ways that we can make a carbon fibre wheel using automated methods that are going to be faster and more cost effective. So our first iteration of the design involves a two-piece wheel where the disc, or the central kind of sloped portion of the wheel, is made using AFP, and the rim portion, the round part the tyre mounts onto, is made using traditional hand layout, and then these are joined together during the manufacturing process. But into the future, we'd like to see the number of components get reduced, so you're building everything in that AFP cell and not needing to do secondary processes later. At the moment, they are only suited to a specific type of part. It can't have too tight a curvature or certain features, but for certain components, a lot of current examples are found in aerospace that meet the criteria for AFP. It can significantly speed up the manufacturing process and reduce the cost a lot. The design of the wheels is very much largely done within ANSYS, a finite element package. Specifically, it was done using ACP, which is ANSYS's built-in composite analysis module. So this allows me to, the type of material I'm using, how the material is placed by the AFP robot, and then look at how the wheel deflects, what kind of stress it sees, and if that'll be suitable for its operation. So within ACP, I iterated the design by trying out different materials, different fibre orientations, different thicknesses to find an optimised design that met our loading requirements but also didn't have too much unnecessary weight. Following analysis in ANSYS ACP, the specialised AFP programming software called VeriCut is used, and this is used to validate the actual manufacturing process, so we can see that the machine can create the geometry that I've come up with without any collisions or any issues. For AFP, obviously we'd like to use it in more than just the wheels, so some other areas that we envision it being really powerful within Sunswift racing is in grid stiffening of body panels. So rockets and stuff, they often use what's called an iso grid structure, which allows them to have a very thin metal surface that's reinforced in the back with a grid that makes the component very light and very stiff. We can actually use automated fibre placement to make grid-different composite panels for our cars, and this will let us build extremely thin body panels that save a lot of weight but still don't sacrifice in stiffness. Finite element analysis can tell you where the stress, what levels of stress different parts of a particular component have. So one thing this allows you to do is optimize your design. So a process called generative design basically sees the computer analyze the model, see where the peak stress is, see where the low stresses are, and then it will automatically remove material where the low stresses are, and do that over and over again until you come up with typically a very organic looking shape that only has material exactly where it's needed to take the specific load requirements for that component. On Sunswift 7, we utilise this process to make our front and rear suspension uprights. They were designed using Autodesk Fusion 360 and its generative design function. And by feeding in a set of load requirements and geometrical constraints, we were able to come up with an extremely optimised shape that was minimum weight. And this was subsequently 3D printed from aluminium. And then some post-machining work was done on a CNC mill, and the parts are ready to fit into the car. And into the future, I definitely expect to see 3D printing becoming more prevalent across all industries. So the reasons for this are you can rapidly prototype parts with minimal costs, so there's no need to get molds produced for a molded part, or there's no need to do complex CNC machine programming. You can send the 3D printer a file and it will just create whatever you would like it to make. And within a production sense, this means that you don't need to create specialised tooling for parts. So within aerospace, a lot of the complex parts that may only need to be made a couple of times and require very expensive tooling can be made in a 3D printer with no specialised extra tooling requirements.
Hi, I'm I'm Tom Kellyback. I'm the Technical Manager of SunSwift Racing. I have a bit of an involvement all over the car, working between the electrical systems, the embedded systems and telemetry systems, and I'm just going to talk you through a little bit about some of the cool stuff we do here. One of the cool things we do here at SunSwift Racing is we monitor pretty much every parameter around the car. We have around 300 data points that we monitor live on the car as we drive it. So things ranging from tyre pressure, suspension travel, panel temperature, panel efficiency, all sorts of stuff. You name it, and we probably have a sensor for it on the car. And one of the interesting things about our telemetry system is actually how we interface with the infrastructure which we drive around. Cars at the moment often use 3G, 4G, and some of the latest cars use 5G technology to be able to connect your car to a cellular network. But what's interesting about the current vehicle market is that this telemetry is typically used just for things like infotainment, the occasional like music and Spotify streaming services to be able to play directly to your car instead of via your phone. And we have a slightly different lens on our telemetry system as to a conventional car. One of the biggest challenges of SunSwift Racing was being able to monitor the car without any of our own infrastructure as we drive through the outback of Australia. And I'm not sure how many people watching have driven through the outback of Australia, but there's not very much around there. And so what our key issue was being able to monitor the car in real time with super low latency, but without the need to drive a support car 3, 4 or 1 kilometre behind it. We wanted the car to be able to really operate independently. After quite a bit of research, we ended up settling on a low power WAN solution. So what that essentially means is that instead of using a typical high bandwidth, low latency cellular network like you might use on your cell phone, we actually use a technology called narrowband IoT. This network operates very similarly to a regular phone network. Here in Australia, some of our cellular providers have really extensive network coverage throughout the country. However, when you're limiting yourself to 3G, 4G and 5G technologies, they tend to be limited to high density, high population environments. The advantage the NB-IoT network provides us is the ability to have basically an internet connection in the middle of nowhere. So we do still rely on a very small amount of infrastructure, but with one narrowband IoT tower, we're getting much larger range from anything we would normally get from a typical 4G tower. What this means is that SunSwift 7 can drive pretty much anywhere in Australia and still have a very useful and powerful internet connection. This allows us to have a team of engineers monitoring the car in real time from literally anywhere in the world. And we can see things like cabin temperature, the status of the lights inside the cabin, tyre pressures, and really be able to prevent issues happening before they occur. So by moving our data analysis off board, we're able to utilize much higher compute that would normally be available on board. What this means is we're able to do some predictive analysis on all the data points we have, and we're able to actually have predictive monitoring rather than reactive monitoring. And this opens up a whole bunch of more doors and really enables us to extend the lifespan of any single component because we have that predictive capacity. Here at SunSwift Racing, by caring about each and every component on its own, when combined together, we have a much more sustainable and reliable product. At the end of the day, we are an environmentally friendly and environmentally focused organisation, and telemetry is just one of the many ways which we achieve that. By adopting this predictive telemetry and data analysis of every component on a car, when scaled up to mass production, this can mean that service intervals are further apart, meaning your product lasts longer, the cost of each vehicle decreases, ultimately reducing stress on supply chains. So really, these small little changes and small bits of functionality which we're developing at SunSwift Racing, when scaled up, can have a huge impact on a massive industry.
Thanks, Alex and Tom. That was a fantastic run-through of SunSwift. We'll jump back to you guys in the studio.
At Epicenter Consulting Engineers, we are passionate about the projects that we deliver and the outcomes that we deliver as part of these projects. We believe that these project outcomes positively impact people's everyday lives. We deliver these outcomes by communicating and working collaboratively within project teams to understand our clients' requirements and to deliver optimal engineering solutions to meet these requirements. We understand that our work isn't about providing innovative technical designs. Our work isn't about delivering a commercial, industrial, healthcare or residential project. Our work is actually about delivering outcomes for the people that use, live in and rely on the projects that we deliver. Our work delivers joy to people in good times and brings hope to people during difficult times. Our work delivers improvements in the quality of life of people in our communities who require care and assistance. Our work allows people and families to form stronger friendships and bonds by maximising the enjoyment they get from their downtime. Our work enables people to reconnect and reunite with family and friends. Our work helps preserve the past as well as helping to shape the future. At Epicenter, we help our clients leave their mark on the world and help make the world a better place for everyone.
Thank you, Chris and the team at the University of New South Wales. Next up, we are going to be hearing some personal messages from Engineers Australia.
The impacts of health crises and economic shocks triggered by COVID-19 have been profound. In Australia, the initial lockdown saw the end of 29 years of economic growth, while the Omicron strain has seen virus testing resources overwhelmed and almost every part of our economy affected. These and similar impacts across the world have highlighted the need for improved public health capabilities and more resilient supply chains. COVID-19 also emerged amid an even greater threat to health and economic well-being, the worsening impacts of climate change. None of this has happened in a vacuum. Many of the practices that increased our risk of exposure to novel pathogens, such as unrestrained development and the destruction of wilderness, are also fueling climate change. Now that government and community responses to the pandemic have shifted away from short-term stimulus, build back wiser should be the guiding mantra in every sphere. Whether it's rapid and dramatic scale-up of climate change mitigation, adaptation, and resilience efforts. The events of recent years have had a profound impact on Engineers Australia's outlook and activities. Just to take a few as examples, sustainability has been a central focus in our Learned Society review, and that's an ongoing comprehensive review of how our volunteers and employees work together for the benefit of the profession. We hosted our inaugural Climate Smart Engineering Conference just last year in November 21, and we launched the Climate Smart Engineering Initiative, a continuous dialogue with our members, with the profession, and the broader society on climate. Climate change is a core priority of all our member groups, be they colleges, divisions, and our staff, through a project that we call the External Voice. This is our flagship policy development initiative. Our advocacy and public communications have regularly addressed supply chain issues and supply chain resilience. Our profession has an integral role to play in engineering this future. Engineers will be key to designing and managing systems and technologies to overcome climate change, strengthen our health systems, and bolster supply chains.
COVID-19 is a global wake-up call and one that has necessitated a rapid global response. And what COVID-19 has shown us is that when political will is directed at implementing public health policies at short notice and on large scales, it can be done. This is the kind of effort and the kind of choices we urgently need to address the climate crisis. Action to address climate change must not be kicked down the road. Indeed, as a leader of change and transformation, I'm very familiar with a saying, never waste a crisis. Our current COVID crisis has thrust upon us an opportunity to recalibrate what really matters and to imagine and create a profound systemic shift to a more sustainable economy that works for both people and the planet. Building back better must mean restoring our economies, our communities, and our planet at the same time. As countries adjust and rebuild their economies to flourish through and beyond COVID-19, recovery plans must not just aim to restore economic activity, but shape the 21st century economy in ways that are clean, green, healthy, safe and resilient. Integral to our recovery plans must be the triggers for immediate, systemic and accelerating reductions in CO2 levels in the atmosphere. The science is clear. Without deep and rapid decarbonisation of our energy and industrial systems over the next 10 years, we will never reach the Paris Agreement goal of limiting temperature rise to 1.5 degrees. Net zero emissions must be achieved well before 2050. Engineers are pivotal and responsible for implementing the energy and industrial transition to a sustainable society. And as the voice of the profession, Engineers Australia is committed to leading this charge.
Engineers Australia recognises the immense challenges and risks, as well as the opportunities arising from climate change, and the critical role the engineering profession plays in local and global efforts towards preventing, mitigating and adapting to the challenges and pursuing the opportunities. In 2021, we formally launched our Climate Smart Engineering Initiative, a program of work that is focused on very pragmatic initiatives that will enable our profession to be more influential and have more impact on climate change issues. We're deep in consultation with our members and other climate change and technology experts about what these initiatives might be and how we might prioritise them. We need to understand which ones are the most valuable. What can we do that will make a substantial difference? What can we do that will help to unleash valuable progress towards a healthy planet? We aim to have the work plan in place and to commence implementation in the next couple of months. The initiatives will aim to deliver valuable and practical benefits on the challenges and opportunities presented by climate change for our members, the profession and engineering organisations, as well as the community, government and higher education. We want to be quite ambitious with the Climate Smart Engineering Initiative. Ambitious for the planet and ambitious for EA in our profession. Engineers need to step up and play their part as a practical and trusted advisor on climate change. We will refine this initiative in parallel with the implementation of its actions as we learn more about what our stakeholders value most. Climate change will be the most significant challenge for the engineering profession and society over the coming decades, accelerating the development and integration of climate-friendly technology and improving the representation of the engineering perspective in policy debates and decisions related to climate change is fundamental to achieving meaningful action and change in the required timeframes. And we're looking forward to continued engagement with our members and partnerships with other organisations and entities to progress this important work.
Climate change will arguably be the most significant challenge for the engineering profession and society over the coming decades. This is why Engineers Australia released an updated position on climate change ahead of our inaugural Climate Smart Engineering Conference last November. It conveys a position that is strongly supported by Engineers Australia's colleges, technical societies and young engineers. The statement called on governments, investors, the private sector and the wider community to work with the engineering profession to accelerate engineering innovation for a swift transition to a sustainable economy. Significantly, we call for action at pace and scale to reduce greenhouse gas emissions, achieving net zero emissions well before 2050. Of course, it's not promises, but practical action that will make this possible. First and foremost is the adoption of existing renewable energy technologies. Engineers must also accelerate the development and adoption of new climate-friendly technologies. But we must not delay hoping for carbon capture and other technologies to become available and affordable at scale. It's equally vital that the engineering perspective is present in policy debates, in decisions related to systems for climate change mitigation and adaptation, and in the means of enabling a just transition for the communities and workforces that are most vulnerable. Again, engineers must work to develop and achieve wide-scale adoption of practical tools to factor climate risks and opportunities into the economics, the design and the delivery of engineering products and projects. It's these sorts of practical initiatives that will enable engineers to fulfil their ethical responsibility to tackle climate change and to proudly deliver the trusted products, assets and services that are the foundation for our future well-being.
One of the most common questions young people are asked are versions of, what do you want to be when you grow up? And then when they're nearing the end of school, what are you going to do next year? I think a better question to ask young people is, what difference do you want to make to the world? What do you want your impact and legacy to be? This invites them to think longer term and in a less constrained way about what their working career might look like. These days, it's hard to imagine many aspects of life that don't involve technology somewhere, and that's where engineering plays its main role. Engineers have so many roles in the technology lifecycle that I think engineering must be the broadest profession there is, spanning numerous sectors, disciplines and sub-disciplines. That's what makes it so exciting and full of opportunities that can suit so many people. But this is also what makes our profession suffer from a lack of clarity on what it is, what we do and what our contribution is. One of my favourite thinkers from the 20th century is Herbert A. Simon, a political and social scientist who won the Nobel Prize. In one of his papers from 1962, he said, "Human problem solving, from the most blundering to the most insightful, involves nothing more than varying mixtures of trial and error and selectivity." He went on to say that the more insightful approaches allow you to see which paths should be tried first and which leads are promising. I think engineers are insightful problem solvers. We draw on scientific principles, analytical thinking, creative thinking, systems thinking, logical thinking, critical thinking, futures thinking, and design techniques to solve problems and pursue opportunities. Karl Popper said, "All life is problem solving," and I think that's pretty true. The OECD says that the world no longer rewards people for what they know, but for what they can do with what they know. And I think that's fairly true too. The complexity, uncertainty in the world right now requires versatile thinkers and doers. Engineers are well placed to contribute just about anywhere in society. It's a very transferable and versatile skill set and mindset, which is why engineers are sought after in other professions and sectors. Engineers seek a deep level of understanding about the systems they're working with. We have to, which is why many CEOs are engineers by training and background. They tend to understand their businesses deeply. So what would I say to young people about engineering as a possible future study and career choice? If you're seeking to develop highly versatile and sought-after skills that can contribute to just about any aspect of society, and if you want to make a positive difference to the world, then consider engineering. The opportunities available to you with this skill set are almost endless.
I've been an engineer now for almost 40 years, and I really have to say it's been an amazing experience. I'm endlessly curious, and one thing I can tell you is that an engineering career is a fascinating career because as engineers, we never stop learning and making progress, building on what's gone before. I'm like a lot of engineers in that I love that aha moment when you solve a problem. That takes creativity. When Engineers Australia asks employers what they value most in staff and seek in new hires, the answer typically isn't technical skills. The most common responses include things like emotional intelligence, creativity and innovation, the ability to communicate and build skills with others, teamwork, a work ethic and taking the initiative, and importantly, a willingness to take responsibility. Forward-thinking engineers and leaders are predicting a split in engineering, with one group leading automation and another group supporting human factors, human needs and experience. As the world continues to rely on technology, an engineering degree equips you with the skills that are essential to our way of living. Your engineering qualifications give you the opportunity to operate across disciplines, across professions, and across industries to create, to innovate, and to problem solve. Engineering will change the world, maybe in a small way, but perhaps in a really big way. You might save the planet, or you might spend your professional life doing what engineers do the world over, working to advance society. We know that engineering touches nearly every aspect of modern life and is going to be critical in creating better energy solutions, cities that function more effectively, and communities that are sustainable, secure, healthy, fair, and prosperous. Almost every industry has engineers in it. So no matter what you're interested, there's likely to be an engineering component. That's true of professional sport. It's true of music. It's true of clean energy. It's true of pharmaceuticals and vaccine manufacturing. It's absolutely true of so many areas. The world is your oyster, and we hope engineering will be the tool that you use to crack your future wide open.
We are over 100 years old. From our youngest days, all we ever wanted to do was create. We don't usually start with an idea. We start with a need.
It could be anything. You need to get over a harbour. You need to fly. You need to put new bones in a broken body. We use the raw elements of the earth, the intricate chemistry of living things, the languages of machines.
Our creations are huge and they are small. They dive into the human body and they fly above the earth.
Sometimes we work individually, sometimes as a team. We exchange ideas and help each other network.
We are at our best when we support one another every step of the way, holding each other up and ensuring we all succeed.
We have not slowed down. We have big plans. We're figuring out how to harness the power of the sun, the chaos of the quantum realm of intelligences greater than our own.
We dream of making our world a better place. We are engineers.
We are Engineers Australia.
We are over 100 years old and we're just getting started.
Thank you so much, Engineers Australia. I am a proud member of Engineers Australia, and some really important messages and a great scene setting for the future of engineering and the importance of this today, World Engineering Day.
Absolutely.
I'm joined on the desk by Tennille, who is going to be sharing what is happening on social media. It is going off. Tell us all about it, Tennille.
Oh my goodness, the hashtag is going insane. I think if you just go and search World Engineering Day, even on Twitter, you're just going to be overwhelmed with stuff, which is really, really cool. I'm going to flick to my screen here so we can just see some of the really fun stuff that's happening at the moment. We are overwhelmed with hashtags. I would really love to see some selfies and some videos of things that you're actually doing in your office or at your events. This is just an overwhelming response so far, and we've only been live on the 24-hour stream for 2 hours. So that's amazing. Some things to highlight. UNESCO has given us a cheeky shout out. Go UNESCO, thank you so much. Hashtag World Engineering Day coming up on our screen. That's really cool. Another one here from Engineering Council. They're actually doing a bit of a shout out for our stream. So thank you so much. Hashtagging World Engineering Day to come up on our live social media program. And then the very last one is actually Australian. One that's very near and dear to my heart, Red R Australia. We work with Red R Australia through some other programs throughout the year. So we just want to say thank you for your support. We really appreciate everything that you do and you're supporting this program. So thank you so much. So please just get those hashtags in. We're going to come up onto the desks probably 2 or 3 times in every region. And we want to see selfies. We want to see events. We'd love to see what you're doing today. So thank you so much.
Thank you so much, Tennille. Hashtag World Engineering Day. Get your shout outs out there and celebrate this incredible day. We are now going to cross to New Zealand and celebrate engineering in New Zealand. We've got an incredible showcase for you for what's happening over there. So over to you, New Zealand.
Kiwis are known for just getting on with things. So when COVID arrived on these shores, we did what we do best. We rolled up our sleeves, stayed kind to each other, and focused on building back wiser. Because never has the need been greater than now to put the mahi in for the future. Ke whakatō muri te haere whakamua. I walk backwards into the future with my eyes fixed on my past. This Māori whakatauki, or proverb, tells us the past is central to and shapes both the present and the future. So it is the actions now that can define us as good ancestors. So let's take a journey together as we show you how we are engineering the future, right here, right now, in Aotearoa, New Zealand.
Engineering is a big deal for New Zealand. It's behind almost everything we do and plays a vital role in Kiwi life. From our homes and how we travel and communicate, to the water we drink and the food we eat. At Engineering New Zealand Te Ao Rangaho, we are unashamedly proud to shout Aotearoa's engineering genius from the rooftop. We're a non-profit membership organisation that's driven to help engineers be the best so they can engineer better lives for all New Zealanders.
Climate change is a reality. It's happening here in New Zealand, and it's happening now. There's overwhelming scientific evidence on the existence, cause, and physical impacts. This is not up for debate. Now is the time for action. We're supporting engineers to be bold and creative in mitigating, transitioning, and adapting to climate change through our program, Engineering Climate Action, helping engineers lead the way to a healthier, sustainable Aotearoa.
Engineers create the world around us, and we want engineers to represent everyone so the world they create is as diverse and inspiring as the people in it. That's why over 50 firms are signed up to the Diversity Agenda Accord, our ultimate commitment to make both the engineering and architecture professions more diverse and inclusive. Signatories adhere to a set of tenets, supply employee metrics, and attend an annual summit at the New Zealand Parliament buildings to collectively discuss how we can keep moving forward as a profession.
To truly engineer a brighter, better future, we need to ensure we've sparked the wonder in the next generation. So this year, almost 24,000 Kiwi kids have been excited about science, technology, engineering and maths through the Wonder Project, Engineering New Zealand's free in-school program. This connects STEM professionals, teachers and students in classrooms as they work through an engaging STEM challenge.
As you can see, for a little country in the middle of the Pacific Ocean, Aotearoa New Zealand is doing a lot to play our part to engineer the future, both on our own shores and for the wider engineering profession.
So, a big happy World Engineering Day to you all, wherever you are.
Ngā mihi nui kia koutou katoa.
Hello and welcome back. We are now going to jump into our hackathon again and hear from some more finalists. So next up is Team Hirepack from Egerton University in Kenya, and their idea might just change the world.
Hello, I am Joseph Ngudero.
And my name is Charles Kenyon. Together, we are Team Hirepack. We are really honored and excited to be selected as finalists in the World Engineering Day Hackathon in 2022.
Please enjoy our presentation of how we're using engineering to turn weeds into forests. Thank you. Hello, my name is Joseph Ngudhiru.
And my name is Charles Kenyon. Today, we would like to introduce to you the sustainable packaging solution, a game changer for consumers and above all, our planet.
Our story began in June last year during a field trip in Lake Naivasha to investigate marine pollution. But our boat got stuck for close to 5 hours in the midst of water hyacinth. However, despite our predicament, it was painful to watch the poor fishermen who couldn't navigate their way back in the morning because their boats had been hemmed in by this weed.
As engineers, we knew that this problem was up to us. If we can send man to the moon, we can find a way to send man across lakes infested by this weed. The stakes are high here, though. Hyacinth causes issues in navigation, fishing, water treatment, irrigation, and electric power production in more than 50 countries globally, and lives have been affected.
In Homa Bay, Kenya, for example, school-going children have failed to go to school for days, sometimes weeks, because of this weed surrounding the island. So, for our final year project, we sought out to clear the weeds and turn them into an economic benefit.
Our lecturers loved the idea, and they suggested that we could also try using other aquatic weeds growing in our school botanical garden. However, we found out that the wetland shrinked, and that its river running dry due to climate change and global warming. The danger is that our school, Egerton University, is located in Mau Water Catchment Area, which is a major source of water for East Africa.
So, we organized for a massive tree planting in school, where we had over 2,674 seedlings planted on zero budget. And that was our eureka moment.
We realized that for every tree planted, we had a plastic bag wasted, and all toxic fertilizers would eventually run off into the river and cause more pollution. We decided to transform this weed into seedling wrappers that biodegrade within 3 to 6 months of planting. We designed these using AutoCAD and simulated using Solid Edge.
Since hyacinth also offers high nutrients of potassium, phosphorus and nitrogen that facilitate plant growth, we do not remove the wrappers when planting and thereby contribute to a circular economy. Because of these nutrients, our test seedlings have shown up to 23% more growth rate than the conventional ones planted using plastic wrappers.
This way, we solve the issues surrounding plastic waste, inorganic fertilizers, and water hyacinth. Meet Lacey, the Egerton University agroforestry manager, as she shares her experience.
People are still looking for an option on how they'll do change from polythene bags to something else that's biodegradable. It's the best. Think about it, Kabisa. Probably will be the first people who have invented something new that will be taking us away from this. And actually it will be something modern.
How many seedlings do you sell per year? Around, I mean?
Wow, more than 100,000.
More than 100,000?
Yes.
So you have more than 100,000 pieces of these pieces lying somewhere?
Yeah, exactly.
Our R&D is further developing this into a wide range of biodegradable products to replace the single-use disposable items like the plates and the tumblers and straws used in events like parties. We are calling this Higher Pack. However, to fully realize this and make them food grade and launch into supermarket shelves, we need funding for 3D molding machine and extrusion machine. This is an initial capital cost of about $5,000.
However, in our action plan to transform societies, people showed interest in our project, and soon we realized that innovations alone will not solve the problem of pollution. That's why we started Adopt a River projects across the country where we mobilize people at community level to clean up a section of the river, thus engaging them on responsible consumption and creating awareness about climate change and sustainability.
We are turning movements into real action through a wider team of engineers and youth who want to see change. Now, when the fourth wave of the pandemic struck, we still have the team running through Zoom and social media platforms.
Our project has so far won the East Africa Youth for Climate Action Award and is continuously changing socio-economic livelihoods.
Thank you.
Wow, what incredible work, Team Higher Pack. Well done on submitting your entry and becoming a finalist. We're now going to hear from another finalist, which is Team iCity from Harbin Engineering University in China.
我是王新奇。
我是智卓。
我是陈文涛。
We are Team iCity. We are very excited to have been selected as a finalist in the World Engineering Day Hackathon in 2022. Please enjoy our entry, Human, Ocean, and Future.
As the Earth is rich in marine resources, to make sustainable development and reduce the use of energy and resources, the team has proposed an engineering scheme for the use of marine renewable energy for power generation and desalination. The scheme makes use of wave energy, salt energy, and temperature difference energy for energy supply. Furthermore, the aim of the scheme is to achieve a mutually beneficial symbiosis with ocean, adhering to the concept of sustainable development and aiming to achieve carbon peaking and carbon neutrality, effectively driving economic growth. Hello everyone, we are Team iCity from College of Intelligent System Science and Engineering, Harbin Engineering University, Heilongjiang Province, China. My name is Xinqi Wang. I will introduce the first part of the Ocean Energy Development Scheme, the use of wave energy. There are good prospects for collecting wave energy to convert it into electricity and harness it, because the wave energy is rich in Fujian, Guangdong, and Hainan in China. The wave energy scheme has a mature wave prediction system, which consists of two parts. One, the long-medium-term wave prediction algorithm based on LSTM neural networks, which can determine the optimal placement strategy for the WEC. 2. The very short-term wave prediction algorithm based on system parameter identification, which provides accurate phase and amplitude of wave motion in very short periods of time. The estimated wave are used as input to control the PTO system of WEC, enabling the device to withstand the impact of waves on the mechanical drivetrain and increasing the energy conversion efficiency.
Thanks, Wang. I'm Wentao Chen. The total amount of salt energy resources in coastal areas is large, and it has huge development space and prospects. Therefore, we consider eliminating the principle of electrical eel power generation and use a larger amount of salt energy resources to obtain clean power resources. In short, the device is composed of a large number of asymmetrically structured biometric cells. The cell has the structure of a voltage gate sodium ion channel that exits only on one side. When it opens, a potential difference is created due to the flow of sodium ions. Eventually, thousands of cells are connected in series to create hundreds of volts to generate a usable current.
Thank you for your speaking. I'm Zhuo Zhi. In this part, we use the temperature difference of seawater as energy source to realize the two functions, which are power generation and freshwater output. The whole system can be divided into two parts. Firstly, the liquid ammonia is heated to steam by the warm seawater in the evaporator. The steam can drive the turbine to produce electricity. The gas from the turbine enters the condenser and is condensed to liquid by the cold seawater, and the process is repeated to produce electricity. Additionally, the other part of the system vaporizes the warm seawater rapidly and then uses the deep cold seawater to condense the steam to liquid to produce fresh water directly. Therefore, the system can complete electricity generation and seawater desalination at the same time.
Overall, the scheme uses clean energy in the ocean to generate electricity and desalination, saving fossil energy and reducing carbon emission in short term. It effectively deals with the shortage of fresh water, alleviates the global warming, and contributes to sustainable development in long term.
In addition, it will maintain the independence of national energy supply and provide a large number of jobs for the country to promote the economic growth, which is in line with the concept of mutually beneficial symbiosis with ocean.
Due to the COVID-19, we can only exchange and discuss through WeChat. In the competition, we consulted a large number of materials together, analyzed and proposed the solutions from multiple angles. Finally, we finished the game efficiently and independently. We hope we can build back wiser,
engineering the future.
At Sydney Water, we want to create a better life for our customers through world-class water services. We want our cities to be thriving, livable and sustainable. Traditional custodians hold a continuous and ongoing relationship with country, nurturing the land and waterways. Caring for country is everyone's responsibility, and we want to play our part. Our city already has a variable climate, and with climate change, we will have to cope with events not yet experienced. It will affect everything we do. Changing rainfall patterns will affect our water sources. Changing soil conditions will affect our network. And floods and rising sea levels will impact our wastewater network. We acknowledge our customers want a resilient future. We understand that the future of our city and climate depends on the choices we make today. Our teams have been showing leadership through our climate change program. It has two parts. The first part, abatement, is about reducing our emissions to lessen our impact on the climate. We have committed to net zero carbon emissions in our operations by 2030 and in our supply chain by 2040. We will embrace circular economy principles to turn waste into energy. The second part is adaptation, reducing the impact that climate change will have on us. We will build resilient assets by actioning climatic risks. We will build a resilient water supply by diversifying our water sources to include more rainfall-independent water and invest in water conservation. We also know we can help our community. Our city is growing hotter, and heat waves and extreme heat will impact the livability of our city. Water plays a critical role in urban greening and cooling. We will play our part to incorporate water into the landscape to build more livable communities. We are committed to our vision of creating a better life with world-class water services and with a focus on achieving together for our customers and the environment. We can all contribute to the legacy of tomorrow.
Another fantastic entry into our hackathon. Well done, judges, on selecting these incredible finalists. We are now going to cross for our final section on the University of New South Wales and find out a bit more about what they've been up to. Over to you, UNSW.
Technology has given us medicine, entertainment, comfort, and convenience. It's given us ways to capture moments, tell stories, create, and learn. These same technologies, in the form of waste electronics, is the world's fastest growing problem, causing pollution in the environment and irreversible health problems in developing countries. Instead, we can utilize waste electronics by reusing components and recycling materials. And by implementing robots, we can bypass the hazards and costs of manual disassembly. But every piece of e-waste is as unpredictable and unique as the people who used it. Any product could have any fastener in any location. The possibilities are endless. So we're developing a robot to be able to perceive, think, and act accordingly to help stop waste electronics from, well, going to waste.
Hi, this is Gwendolyn Fu, and I'm currently reporting from the state-of-the-art Robotic Disassembly Lab at the University of New South Wales in Australia. I'm here to celebrate World Engineering Day today by showing you what we've been working on at the Sustainable Manufacturing and Lifecycle Engineering Research Group. So let's go on in and take a look. Here, we're developing a sustainable solution to address the electronic waste like these old discarded LCD monitors and keyboards. More and more of these electronic products are being disposed of every day with increasing technological advancements. If left unaddressed, these waste products containing toxic chemicals and hazardous materials end up in landfills, harming natural ecosystems. These materials can instead be reclaimed as high-value metals for manufacturing new products, easing pressure on future supply chains. If we move over here, we have our disassembly robot, which helps to do exactly that. By taking these waste products apart, we can easily reuse and recycle parts and materials. And best of all, no human workers are exposed to the safety risks of manual disassembly. This research is a vital step towards achieving the United Nations Sustainable Development Goals and highlights just how we can build back wiser from discarded toxic waste to engineering the future by recycling and reuse. So, if you want to change the world for the better, become an engineer. Happy World Engineering Day.
We need to encourage girls to do engineering. It's not a boys' world, it's a girls' world as well. My name's Cassette and I'm a fourth year mechatronic engineering student at UNSW Sydney. There's this protege program where students in years 2 above get to mentor a person from first year. It's a really welcoming community and you always feel like you've got friends around you, which is really nice. I'm looking forward to doing the industry mentoring program to learn a lot of professional skills, and that's really important for the industry. It's a support network, but it's also something that will give you skills that you need and you'll take on through to life. I find all the Women in Engineering Society and Women in Engineering programs really beneficial for girls. You need a community like that to feel safe and happy, especially for their future as an engineer and as a leader.
Thank you so much, University of New South Wales, for celebrating World Engineering Day with us. Awesome to see your Women in Engineering program. Thank you so much for sharing that. Over to you, Mel. We've got some exciting things happening on social media with the hashtag World Engineering Day. So if you haven't jumped on online yet and done a shout out, get onto it. Mel, what have we got? We've got some cool footage on the screen happening.
Check out the wall. Check out the wall behind us. It's amazing. This is just the start of the day. We've got 24 hours that we're going to be checking out the social media at least about once an hour. So that's why we're coming in thick and fast, because you guys are posting like crazy, which we love to see. I'm going to point out a few key things. You can see the wall behind us that we're actually basing all the pull-outs on. You can actually also see it on our homepage. If you just scroll down a little bit, you'll see that. But don't do it right now because we're going to focus in on a few bits and pieces that I think are really super cool. Now, especially if we can share my screen, here we go. All right, look at this. This is starting up. So Case that's working on the Parramatta Light Rail by the looks of it. They are putting a post out there to congratulate all their great engineers and yeah, that looks amazing. Okay, that photo was not taken today, but it still looks good. Next up, now this one, I love these ones. I am absolutely thrilled about. They are just posting these handwritten notes, thanking engineers. What's it say? I'm thankful for engineers and the innovation of 3 further developments in space exploration. I'm thinking that's innovation and further developments in space exploration. Thank you. Yeah, thank you, Connor. That's a great guy. That's great. That looks so good, doesn't it?
Awesome work, Connor. Love your
I know.
shout out. Can you thank an engineer today? Maybe you're not an engineer and you would like to celebrate by thanking an engineer, or maybe there's something that you use every day that engineers invented and you want to thank whoever invented it because you might not know. So a day for celebration here today. Mel, have we got any more shout outs?
I've got so much more. Okay, so this is from Waterline. So these are all Waterlines. And Randall wants to thank engineers for changing the world. They so totally have changed the world. I'm loving engineers. And let's see, who else have we got here? Charles, and for inventing a universal serial bus. That is
I don't know what that is, but I'm sure that is
specific.
helpful for someone. It's very specific. It must be very helpful for you.
That's right. What else have we got? Okay, this is Jess, project coordinator. Oh, close to my heart. I too am a project manager. I want to thank engineers for creative solutions to real-world problems. And we are seeing that in this hackathon over this weekend. These are just newbie engineers, like people that are just starting, and they are already finding solutions for real-world problems. So thank you, Jess, for putting a spotlight on that and for posting it. As I said, Waterline, you're doing a great job here. I've got another one, and this is Mel. Ah, good name, Mel. I want to thank engineers for flight. Oh my God, where would we be? Okay, we'd know where we'd be if we couldn't fly, but because we haven't done that for pretty much 2 years. But Mel, I'm wondering what the story is behind that because it's again another very specific. I'm loving it. Now, a little bit of a video here. This is from our hub sponsor. This is awesome. Okay, so this is a little taste of what's to come in. Oh, where are we? We're in Australia at the moment. In about 6 hours. No, this is Ghana. No, so about 9 hours. We are going to be crossing over to the African continent and Ghana, and all the engineers over there. We've had amazing support, and they've got this great promo that's running at the moment on their social media. And as you can see, just a taste of the brilliant work that we're going to be coming on to. Look at that aeroplane on the field. That's amazing. So inspiring, these engineers. All right, I've got another one here from Downer. So this is a good Australian one. And look at the size of that truck. Oh, okay, we've got coming up in the, before we finish up in Australia, we've got some things for kids. And what kid doesn't love a big truck? So that's a great one coming up. And thank you. Oh, that's a picture of Chloe. So thank you, Downer, for posting and in support of World Engineering Day. This is a brilliant feed. Now, we are focusing on Instagram and Twitter. So if you've got any of those accounts, please hashtag World Engineering Day, and we will grab that. I'm going to go back a little bit. You can see how quickly and how much is coming out in the feed. I'm just got the page pulled up at the moment, and you can see that there's a lot of events being promoted. A lot of our posts are coming up there as well, but there's things that are on Twitter. There's a Twitter live I've seen. Oh my goodness, this is moving so fast. What's this one? This one's a video here. Can we play that one? Oh, that one's not playing, but that, where is that? Delta Ultima Frontiera. All right, so we'll have to come back to that. But geez Louise, these are different languages and everything. It's all coming through. So I want everyone to what was your question that you wanted to ask?
Could you thank an engineer today? How would you like to celebrate? Maybe you could pick up on the theme, which is build back better. Maybe there's something you want to see to be built better in the future. Maybe it's climate resistant infrastructure. Maybe it's dealing with some of the challenges like the pandemic, the floods that we're having. Have you got some ideas for engineers? Get creative. #World Engineering Day. And we'd love to feature you on our social media wall and our spotlight on social media. As Mel said, there's going to be many sessions coming up over the next few hours. So we'd love to give you a shout out and hear from you. Thanks so much for being here on the desk, Mel. We are going to hear again from our partners, Engineers Australia.
Enoven is one of the largest EPC contractors in South Australia. With our extensive experience in electrical infrastructure projects and connection works, these were both major factors in SA Water selecting Enoven as their key delivery partner on the Zero Cost Energy Future program. But it's our unique combination that differentiates us. We have a highly skilled, truly dedicated workforce that is spread right across the state of South Australia, and they all have a DNA and a proven track record of working collaboratively and proactively with our customers, which was always going to mean that SA Water could depend on Enoven to deliver this world-class innovative program.
Water and wastewater services are energy intensive, and as an organisation we've been working for many years to optimise our energy management program. We're now taking that energy program to the next level through the development of our Zero Cost Energy Future project.
This is a marquee project to deliver zero cost to SA Water, and through that make sure we make a difference in every South Australian's life.
Our innovative program is about sustainability. We're working to sustainably reduce our operational expenses and also to reduce our carbon footprint to help with climate change. To achieve this, we will increase our generation capacity by 242 gigawatt hours per annum, plus 34 gigawatt hours of energy storage. Enoven are our partner who are helping us deliver these outcomes.
The solar PV and battery storage initiative by Zero Cost Energy Future program is a really unique one. Initially, when we were brought on, we had over 90 sites that we were considering, but through strong engineering optimisation, we were able to reduce that to 33 sites across the state and still achieve the 242 gigawatt hour requirement for SA Water.
So a normal solar farm would have one typical racking solution. So this program had up to 33 different sites, totaling 154 megawatts. Each site had its own unique requirements that made it impossible to select one single racking solution that would best suit every site requirement. We have some amazing engineers of multiple technical backgrounds that have come together to work on the program to help determine the most suitable technical racking solution for the project. Across the program, we've ended up using up to 5 different racking solutions, ranging from tracking, mixed tilt to innovative high-density solutions. Each site had its own racking technology perfectly selected to suit those site requirements.
This project is unique in so many ways. None more unique than trying to achieve 33 connection agreements within an 18-month period to deliver on SA Water's objective of Zero Cost Energy Future. It's been a rapidly moving project and we've had to push through any challenges that have been thrown at us. We've even had a global pandemic during this program and that hasn't slowed us down. Procuring in advance of design has meant that we've been able to ensure that logistics processes have held up during COVID-19 and we have not missed one date as a result.
Really fits our capability and was an opportunity for us to provide full engineering, procurement and construction services to a brownfield environment.
This has been a really exciting, rewarding and challenging project to be part of. There's been a lot of challenging situations thrown at us throughout the process, but we've managed to bring it together safely, cost-effectively and sustainably, and it's a project that I'm really, really proud to say that I've been part of.
We've developed creative solutions on this project and pride ourselves on thinking outside the box.
We never compromise on quality or the safety and well-being of our people.
The most rewarding part of this project has been ensuring that South Australians have been able to support us in delivering what is ultimately a community project for the benefit of everyone. We've employed over 30 different contractors across the program, including 4 to 5 Australian and Torres Strait Islander businesses. And it's absolutely clear to me that we've made a difference with SA Water to deliver a zero-cost energy future.
Enerven actually play a really important role within South Australia. We build and maintain most of the infrastructure that keeps the state going. And it's landmark projects like this that means there's never been a more exciting time to be in the industry. We help lower costs for our customers, but more importantly, we're providing a more sustainable future for the next generation.
Building a solar farm isn't complex. Where Enerven excels is providing a fully vertically integrated solution to the solar market, from high voltage connection through to panel installation. What that means is that the customer can have one EPC contractor delivering its full scope. Enerven is born out of an engineering business, and that drives us to take the time to really understand the requirements of the customer and ensure that we are delivering the most efficient and effective solution for their requirements. Being able to take a world-leading project and deliver it in South Australia for South Australians is extremely rewarding for me.
At Enerven, we have the engineering know-how to tailor our solution to achieve your goal in any climate. We're connecting you with tomorrow.
So what are we going to do about it? What are we going to do as leaders? What are the behaviours that we need to find in ourselves? And what are the behaviours that we need to draw out of our followers? If the delivery of engineering for the built and natural environment needs us to understand politics and psychology and civilization and culture and influence, and I really do believe it does, what can we do to make sure that we are rising to the challenge? I think the first step is to be curious. The complexity of the way in which our arena intersects with its context and our current crises means that we must be lifelong learners. We need to build our skills over our lifetimes, and while it may not always feel like it, we do have the time to do it. If you subscribe to the idea that it takes 10,000 hours to become competent in something, then a full career of 40 years allows you to become competent in about 8 somethings, and that's just in your working hours. The modern world is exciting and ever-changing, but learning how to use a new app on your phone may seem uninteresting. It's really easy to become impatient with new technology or to be frustrated that at your age you have to learn another tool, but it's almost always worth it. I was recently the co-director for Arup's annual directors meeting, a 600-person meeting that we had to do using virtual platforms. We decided to use a spatial sound platform, which is a platform where you can set up a virtual environment. You can see that here. And the people you can hear are the ones that are closest to you, just like in real life. It was a somewhat risky technical choice. We ran everything, all the plenaries, all the breakouts, all the on-demand video, all the casual meetings through the platform. And we managed that risk through recording everything we could in advance and making sure that live stream was available in multiple ways so that when it went wrong, we knew what we were going to do. But the real risk wasn't actually the technology risk. The real risk was our 600 directors, all of whom are, of that age, my age, and getting people to spend the time to learn the platform, to engage with what they called a gaming engine, and to get themselves comfortable was what took the time and the political skills and the bravery. But afterwards, and this is why I say it's almost always worth it, the pride that people had from having engaged, from having made it work for them, and the rejuvenating effect of that pride was actually the real win. In some ways, this is a completely banal example. It's just a meeting platform. But I think it's really illustrative of what it takes to engage with these issues. Everybody had to learn something new. Those of us running the project needed not just technical skills, but political ones, social ones, and psychology ones. Even the simplest programs of work need us to have more than one competency to work far beyond our core skill. And many of these skills are learnable. They're learnable on the job and they're learnable off the job. And I have 2 further thoughts about where and how we apply our creativity, curiosity and creativity, actually. I said somewhere near the beginning of all this that mine is a design mindset. And I think of engineering and construction as big, complex design problems. And I also said that my career has had many threads, one of which has been digital. When I first started to get involved in digital working, I came across this field of design thinking. My design references earlier, Charles Eames and Einstein, were definitely design thinkers, and the ideas have been around for decades. But design thinking has really come into its own with digital. In digital, it's a field where things are being designed all the time by people who don't necessarily think of themselves as having a traditional design background or think of themselves as designers full stop. And there needs to be some kind of way of systematizing the process of coming up with ideas and evaluating them. Ideas about understanding the problem properly at the outset, about using personas, defining pains and gains, the need to iterate, to have phases of both divergent and convergent thinking, are all core to the delivery of engineering work because they are core to the act of design, the act of moving the world from the current state to the preferred state. To my mind, this has now come full circle. When I first read about design thinking, I couldn't quite believe that there was a need to systematize thinking. I come from a design background. But on reflection, I realized that there was an enormous benefit in being explicit about the steps and the processes. And we're now at a point where many of those in construction don't think of themselves as designers, although we clearly are, in the broadest sense that we're always working towards a future preferred state, and it's time for us to learn these processes again in their new and transformed state. This kind of ideas transfer, refinement, and editing is typical of the kind of thing that we can learn if we're curious and prepared to spend some time with adjacent areas of expertise. My second thought on this is that many of the skills we need are not technical at all. They may not even feel explicitly skill-like. They're the things we learn when we're not at work. So the design thinking process and most of the literature around creativity emphasizes the need to ideate and iterate. That means having good ideas and choosing between them. And where do good ideas come from? Often they come from thinking about our particular and really well understood problem in a new way. So in my case, mechanical engineering. From drawing links between different kinds of problem, from the point of intersection between strong expertise in an area and a new perspective. It's about thinking differently about something that you already know quite a lot about. And those new perspectives really don't always come from sitting at your desk and working the problem, although that is absolutely a step in design work. They tend to come from all of the other things that you do. In my case, that might be teaching kayaking or working through a dressmaking problem or puzzling through a new piece of music. But getting the result from curiosity means diving in deep enough to establish enough expertise that you can be open to thinking about new ways of doing things. You have to be able to be good at something, getting to this idea of mastery before you can actually change the way in which you do it. And in order to know why you want to change it, you have to have other experiences and other influences to bring in those new ideas. And then you have to be able to evaluate them all. So we've decided that we want to lead. We've dived deeply into our own arena. So we have enough expertise to be able to do things differently. We've used our curiosity to become knowledgeable about the crises we have to address and the changing context of our work. And we've also used our curiosity to build a range of skills and perspectives from activities in both our work and in our broader lives. So we know where we are, we understand what we want to change, and we're equipped for the expedition. What else do we need? I think we need some bravery. Leadership is a superhuman activity. No matter who you are, you will need to do something that is outside of your comfort zone. That might be as simple as being the first to do something, to lead by example, when it's not clear that anyone is going to follow you or that your way forward is the right way. That might just be my introversion speaking. For me, being out at front or the focus of attention isn't always a comfortable place to be. So for me, one of the key things is to work out what it takes to put myself in a leadership position. In trip leading for kayaking, we talk about the leader having to get to the position of maximum usefulness. This boat isn't a kayak, but the guy standing up and the one without the oar are the people who are in the positions of maximum usefulness. Those are the two people who can actually stop this boat getting surfed onto whatever it is that is making these waves break. But to the point, the answer to what you need to make yourself brave is likely to be quite personal. And for me, it's understanding where I have strength, and that's normally around knowledge and experience, or about using my own particular perspective to see a problem in a different way. And it's also about understanding where I don't have strength, and it's okay to admit that I don't know and that I do need help. Which brings me to the final part of this, the three crises that we need to address: climate change, health and biodiversity are not point source problems. They're the cumulative effect of many decisions made by many people, each of whom is responding to their own particular drivers and managing their own risks. So resolving these problems is not a question of finding only the right lever and pulling on it. It's a question of finding the points of maximum impact within our own arenas, using the tool sets we've built individually and bringing the courage to both lead and act, and then building teams that can multiply individual effects and manage the overall risks together. As an example of this, I've been working as a member of the advisory board for New York's Local Law 97. As written, the law allowed for a lot of flexibility in the way that the detailed rules can be developed. And so an advisory board was included in the law to provide advice about the approach. The board was designed to have many different perspectives, from environmental justice to real estate, from engineers and architects to client advocates and utilities. In operation, the board has divided up into working groups to which we have co-opted even more people from across the whole of the industry. There may be as many as 200 people working on this. With COVID, we got a slightly slow start. Getting to know a lot of strangers and finding each other's strengths in virtual meetings is a challenge of our time. But with regular meetings, we have found those strengths, and the working group that I am co-chairing with a climate lawyer is beginning to turn out advice. Each of the working group members has been able to bring their own unique skill set, and those skill sets have grown as we hear other perspectives. And over time, everyone's ability to contribute has also grown. Working in collaboration has also allowed us to share what we know so that we can do more than any of us could have done alone. This pattern of collaboration is critical. Sharing skills and responsibility also helps to manage risk. It brings the best ideas to the biggest problems, and it can help you be brave because it provides some reassurance that you are not working alone.
Thank you so much, Fiona, for that insightful perspective on engineering and what the future could look like. Particularly loved the section on design thinking, so important so that we can think to solve challenges in this unique way. We're now going to turn our attention to the future of engineering in terms of the next generation of engineers. So if you have any budding engineers in your family, or if you have children who might not know what engineering is, this next segment is perfect for them. We're going to take a look at the next generation of engineers and hopefully inspire you and your children about engineering.
And I have one last question.
What is your last question?
Do you think your job is boring?
Well, it's actually a little bit hard to remember.
Coming up with new ideas and concepts of how things can go better around trains.
There's some bits where you are making things, and some bits where you're just doing little bits of experiment.
Design stuff.
Writes emails and talks to people.
I think it's where she tries to stop climate change.
Go to work and earn money. To buy some toys for us. No, to buy food. And to buy toys.
My name is Melvin Bollas and I'm a mechanical engineer.
Andrew Ballack, estimating leader for Laing O'Rourke.
It's Julie McHale and I'm the Managing Director of Engineering Business.
I'm actually a second generation engineer. My dad's an engineer and I guess I saw some really good stuff that he did and I followed his footsteps.
I'm an engineer and I price up and build projects, roads, bridges and other major infrastructure. So I like seeing the things that I've priced and projects we've won being built to change the world for a better place.
I am more poised towards small businesses, so seeing them grow and get to kind of focus in on the technology that they're trying to create and not worry about the governance that sits beside it, and I kind of take that off them and let them kind of get on with the work that they want to do.
What do you like most about your job?
I love that I get to help the really amazing people that I work with to do even better work together.
My name's Mary Stewart. I'm the CEO of Energetics. I'm a chemical engineer and I help large organisations manage the risk associated with addressing climate change So understanding the impact of the transition, things like increases in energy prices, but also understanding and addressing the impact associated with the changed environment.
The hardest part of my job is you never know what you're going to do.
My name's Dominic DiGioia. I'm a mechanical engineer who runs a company that specialises in building services and building services design. As part of my job, we get to build things that are going to be there for a very long time that help communities.
The things that we build and create last for 100 years and even for generations to come.
And I have one last question.
What is your last
Do
question?
you think your job is boring?
I do not think my job is boring, and I actually think my job is quite important because we're making a real difference.
I think it's a good one.
I definitely love what I do.
Was that filmed? Yeah. What? So that's going on the...
When you flush the toilet, your wee goes down the drain. It spins and whirls, goes round and round, and pipes take it away. But don't forget to clean it before sending it out to sea. If it wasn't for the sewage works, we'd be brushing our teeth with we.
I tried it once, made my teeth yellow.
Without the power plant, there'd be no electricity. That would mean no more lights in the night we wouldn't see. No Xbox or Nintendos, no YouTube videos. No trucks, no trains, no trampolines, no factories to make our clothes. If we didn't have them, our lives would be weird. Bridges, boats, buildings and roads would all just disappear. To stop flooding, drought and poison trout, one thing's very clear. We don't need more engine eyes.
We need more engineers. Get it? Engineers.
We must reduce, reuse, recycle, stop burning oil and coal. It pollutes the air and melts the ice and animals lose their homes. Engineers bring us energy from wind farms and the sun. They can even help us use the gas that comes from a cow's bum.
Comes from a cow's bum?
If we didn't have them, our lives would be weird. Bridges, boats, buildings and roads would all just disappear. To stop flooding, drought and poison trout, one thing's very clear. We don't need more engine eyes, we need more. If you've ever played with Lego, then you're an engineer. You could build a spaceship and leave the atmosphere. You could fly around the moon or 30 million miles to Mars. But we need those engineers to make those flying cars. If we didn't have them, our lives would be weird. Bridges, boats, buildings and roads would all just disappear. To stop flooding, drought and poison trout, one thing's very clear. We don't need more engine eyes, we need more engineers. Engineers make a huge difference to all of our lives, and we need more of them. So why don't you speak with a teacher, your parents, or even an engineer to find out more?
Such a great and inspiring video to get the next generation excited about engineering. I am joined back on the desk with Marlene Kanga. And Marlene, we've got a special announcement that we're about to make.
Yes, Felicity, I'm very excited to announce on this World Engineering Day that the World Federation of Engineering Organizations is releasing a new training platform, the WFEO Academy. And this academy will provide training for engineers around the world, as well as develop institutions, accreditation bodies, and professional engineering institutions, and support their development as a framework for the engineering profession.
Amazing. So I think we're going to cross to a video now which explains all about it, and then we're going to get to ask you some questions about the impact of this work.
The World Federation of Engineering Organisations is proud to announce the launch of the WFEO Academy Training Portal on World Engineering Day, 4th of March 2022, with UNESCO and its partners, the International Engineering Alliance, the International Federation of Engineering Education Societies, and the Global Engineering Deans Council. Education for engineers has been a core objective for the Federation since it was founded in 1968 and of the WFEO Engineering 2030 plan. The training portal will deliver on this objective under the auspices of the Federation's Committee for Education and Engineering. This website will provide training and build capacity for accreditation bodies and professional engineering institutions, enabling them to achieve international standards and the requirements of signatory status of the International Engineering Alliance. It will also provide training for engineering educators to develop the curriculum and pedagogies for outcomes-based education that are also a key requirement to achieve these international benchmarks. A third component is training for the qualified engineers, technologists, and technicians for essential skills in areas such as safety, risk, project management, ethics, and leadership that are required across all disciplines and are essential for competent and responsible practice.
I am proud to lead the initiative for the WFEO Academy, which will provide training on demand to all across the world. I hope many will take up the opportunity to learn from experts in engineering education, and that those who participate will be enriched by the lessons learned.
The training materials will draw on the existing webinar resources of the members, affiliates, and partners of the Federation. These webinars will thus gain a wider audience and a greater utilisation. This is a sustainable approach, using the knowledge and goodwill of hundreds of experts that have given their time willingly for the webinars and will build knowledge and skills in the spirit of the UNESCO Open Science recommendations.
The launch of the WFEO Academy on World Engineering Day 2022 aligns with the theme Build Back Wiser, Engineering the Future. The WFEO Academy delivers online training on demand to individual educators and assessors of engineering education programs. WFEO Academy builds competency in practice for qualified professional engineers, technologists, and technicians, and supports the development of strong institutions, accreditation organizations, and professional engineering bodies, addressing the UN Sustainable Development Goals for education, Goal 4, strong institutions, Goal 16, partnerships, Goal 17, but all the SDGs to ensure that no one is left behind, to combat poverty, and also to support a water-secure world. Importantly, this is an inclusive approach, available in nearly 100 languages and scripts. It can be accessed by all, women and men, wherever they are, ensuring that no one is left behind.
The training will be available on demand at any time and any place around the world in more than 100 languages. The content is available at no cost to individuals that are members and affiliates of the Federation. This project is a world first. It uses innovation and advanced technology to make content available inclusively to all. Individuals will be encouraged to register and take up the courses in their own time and pace, and will be issued with certificates of completion with additional bronze, silver, and gold awards to encourage the uptake of multiple courses. We look forward to the utilisation of the WFEO Academy, and we look forward to increasing the circle of partnership and support from all members and partners of the Federation for a sustainable future and a better world for all.
Wow, what an incredible initiative to be launching today, the WFEO Academy. Congratulations, Marlene. That is an incredible accomplishment. It's such a cool initiative because it's global and it's going to make a massive impact and have a huge ripple effect. Can you tell us from your perspective a little bit more about the Academy?
Yes, thanks, Felicity. I'm so excited that this has been launched, and from Australia, in my home country. And as you said, this will definitely have a long-term ripple effect, because many countries around the world have a great shortage of engineers. On average, in the developed world, we have around 100 engineers per 10,000 people. But in many countries in Africa, they have about 2, less than 10, single digit per 10,000. So there's a huge gap there. And for sustainable development and for economic prosperity, we need more engineers, because there's a positive correlation between the number of engineers that a country has and its GDP per capita. So there's an essential role for education and training. And what this academy does is that it provides training for engineers after they graduate, so to keep them competent in their areas of practice. But it also has two other pillars, and that is to train accreditation bodies and professional engineering institutions to build up these institutions, which is goal 16 of the UN SDGs, so that they have strong governance and processes for the work that they need to do. And the third pillar is providing training to engineering educators so that they can develop the curriculum that is needed for engineers of the future and that aligns with the global engineering education benchmarks, which were approved in 2021. And this again is essential to raise the standards of engineering education so that we have better quality of engineers, not just quantity, for the work that needs to be done for sustainable development.
Wow, incredibly important. If there's only a few engineers in one country in the single digits, then it's highly important that they're trained and they have all the tools that they need to be fantastic engineers. So even more critical that they're getting the right skills. And it's also cool to see that there's going to be a huge lift in diversity, I think, from this program, because you're getting people that are living in that world, designing and developing it. What are some of the other reasons that this program is really important? Why the Academy?
So again, this program is important because, as I said, it will reach into countries where we have very few engineers. It uses very cool technology and artificial intelligence to translate the content into some 100 languages. Wow. It's available on demand wherever engineers are, whenever they want to learn. And this is the first of its kind in the world that we know of that is so inclusive. And especially, we've got translation into Swahili, for example, which is a language spoken widely in Africa. Of course, we've got all the European languages, French, Spanish, Portuguese. And then we've got Asian languages, including, for example, Hindi for India and Arabic for the Middle East and so on. So the diversity is enormous and the potential is there. And I hope everyone who wants to take it up will do so. The other aspect is that it's at no cost. If you're a member of a member institution of the World Federation, then you can access this content.
Amazing. I want to go check it out. I want to go learn some new things. It sounds fantastic. What an incredible program. And if you look ahead to, say, 5 or 10 years' time, what would you hope some of the impacts could be from this education and from getting this knowledge out there?
Well, I think firstly, we need more countries or more nations to become signatories of the International Engineering Alliance. This provides multilateral mutual recognition of engineering qualifications. So, for example, Australia is a signatory, as is the USA, Canada, UK. In Africa, only South Africa is a signatory in the whole of Africa. I would love to see more nations become signatories in Africa. And in fact, we are mentoring nations at the moment, Kenya and Mauritius, and hopefully soon Ghana. And these will then, we hope, become centers of excellence that promote those standards of engineering education and training within their region. But to support that work, we need the training. We need to train the individuals, which is where the WFEO Academy comes through. And we need to, most importantly, train engineering educators to develop the right curriculum and to have the right pedagogies, the right ways of teaching engineering so that we do graduate engineers with the right skills.
And as an everyday engineer like myself, what is something that I could do, or people who are in the engineering community, to help support this initiative? Is it getting out on social media and sharing about it? Is it getting involved with your local Institute of Engineers? What can we do to help, Marlene?
Well, I think the most important is to help to donate, to sponsor and support this program. And we do have a sponsorship page. We have developed this on a small budget, supported by the World Federation of Engineering Organizations, but we desperately need more money so that we can expand the program and have more courses. And we've done the development also very sustainably. We've taken existing webinars that have been given by experts in engineering education. For example, at the International Federation of Engineering Education Societies. They have an excellent webinar, which I would also encourage you to visit. And we have selected the pertinent courses and topics that would fit into this program. And the Federation of Engineering Education Societies has generously made these available to us at no cost, and we acknowledge their support. The International Engineering Alliance also runs training programs as part of its Global Reach initiative to, again, increase the numbers of nations that become signatories to their alliance. And they've made their content available, and that will also be shown in the academy. And then finally, for professional development of engineers, we'll be looking to our member institutions, including, for example, Engineers Australia, for relevant content that we can showcase in the academy. This is work to come. We haven't yet done it. We've just started small, but we're really hoping that this will become to a really significant global initiative, which will have impact in every part of the world.
So incredible. What a massive global effort to bring all of this together. So there was a lot of collaboration and communication involved. I'm curious, were there particular topics that people really wanted to see in the content that were really important to create this kind of engineer that you're looking to create in some of these different countries?
I think the most important that engineering educators are looking for is something called outcomes-based education, or OBE. And many in the developing countries struggle with this idea. This is a shift from teaching in a prescriptive way where there's a lot of rote learning and you learn facts and figures. But with outcomes-based education, you bring together the different strands of engineering, for example, to develop a solution. And the Global Hackathon, which I also led this year for the World Engineering Day celebrations, is actually strategically positioned to deliver just on that outcomes-based education. Because you have the hackathon teams coming together to develop a solution and drawing on their various strands of engineering knowledge to put together a sustainable solution. So that's one great example of outcomes-based education, but there are many others. And so we have these experts from around the world that have spoken so eloquently on this subject. And so we have selected some of those webinars to showcase on the Academy platform.
Amazing. I'm so glad you say that. I think that project-based learning and real-world approach is so relevant, particularly for engineers, because we are designing and creating things in the world. And we're actually doing a lot of that at Swinburne University at the moment. That's one of the projects I'm working on. So it's really great to see that it's happening at a global scale now as well, that relevant real-world learning and that integration between industry and education and the future of engineering. Marlene, is there anything else you want to let people know about this program before we hear a word from our sponsors?
Well, I think just log on and have a look, www.wfeoacademy.com, and have a look in your own language. And I hope that you will be amazed and surprised. And I hope that you will take some of the courses and you'll get a lot out of it. Thank you.
Thank you so much, Marlene. It's been amazing to have you here, and congratulations again for everything you've done for World Engineering Day and bringing us all together to celebrate on a global scale. Absolutely incredible. We are now going to hear a word from our sponsors. Yay.
In the early days of Intel, Robert Noyce once said, "Don't be encumbered by history. Go off and do something wonderful." And wonderful, we did. For more than 50 years, we transformed computing, putting Intel Silicon at the heart of innovation. But with all the breakthroughs we made, all the possibilities we created, what's truly wonderful is we did it together.
Let's go higher, higher than we've ever gone before.
And today, as we head into the future, fueled by cloud, AI, 5G, and the incredible potential of data, we are united by what we must do. We're making Intel hardware and software a catalyst for a better tomorrow. To protect our planet, make technology accessible to all, and enrich the lives of every person on Earth. Because the truth is, if you have an idea and Intel inside, you have everything you need to go off and do something wonderful.
Imagine a world without standards, a world built without order, guidelines, or safety procedures to protect us and move our economy forward. Buildings would not stand the test of time. Safe access to power, water, and digital communication would not exist. Standards Australia has improved the quality of life for the past 100 years. Since 1922, Standards Australia has been developing and adopting guidelines that drive Australia forward. From our first committee designing the bolts that keep the harbour bridge together, to the creation of the wiring rules, which remains the most used Australian standard of the 21st century. In 1925, Standards Australia extended its sights beyond our borders and joined the International Electrotechnical Commission. And in 1947, we helped establish the International Organisation for Standardisation. We remain active members of both bodies today. In 1988, Standards Australia was recognised as the peak non-government standards development organisation. In 1997, we were one of the first organisations worldwide to deliver standards publications on the internet. Today, Standards Australia has over 28,500 standards and technical publications, is a world leader in the development of the critical emerging technology standards, and is an international collaborator with other leading standards organisations, creating a safe and sustainable environment both at home and abroad. There are few organisations that have made such an essential contribution to the quality of life while leaving so few footprints in public awareness. Looking forward, we want to continue to empower communities and be a trusted global leader in solutions that improve life, to facilitate standards development to meet the needs of a fast-moving society, to provide easier access, and to deliver critical projects that strategically or economically promote Australia.
The solutions that Standards Australia has developed over the past 100 years have benefited each and every Australian. Our work has never been more important. Join me in thanking our contributors, industry partners, members and staff who have built this valuable national asset. I warmly welcome you to celebrate with us in our centenary year. This year, Standards Australia is supporting engineers and the work they do by sponsoring World Engineering Day. Engineers help build a safe, innovative and sustainable world, and are active contributors to the development of many important standards. For 100 years, Standards Australia has worked alongside engineers and other specialists to provide practical solutions for all Australians. We look forward to our connected future with excitement and anticipation, and working with the engineers of today and tomorrow.
All engineers have a role to play to ensure the UN's Sustainable Development Goals are achievable. As an engineer myself, I'm delighted to celebrate this internationally recognised day. From all of us at Standards Australia, we celebrate with you. Happy World Engineering Day.
At Epicenter Consulting Engineers, we are passionate about the projects that we deliver and the outcomes that we deliver as part of these projects. We believe that these project outcomes positively impact people's everyday lives. We deliver these outcomes by communicating and working collaboratively within project teams to understand our clients' requirements and to deliver optimal engineering solutions to meet these requirements. We understand that our work isn't about providing innovative technical designs. Our work isn't about delivering a commercial, industrial, healthcare or residential project. Our work is actually about delivering outcomes for the people that use, live in and rely on the projects that we deliver. Our work delivers joy to people in good times and brings hope to people during difficult times. Our work delivers improvements in the quality of life of people in our communities who require care and assistance. Our work allows people and families to form stronger friendships and bonds by maximising the enjoyment they get from their downtime. Our work enables people to reconnect and reunite with family and friends. Our work helps preserve the past, as well as helping to shape the future. At Epicenter, we help our clients leave their mark on the world and help make the world a better place for everyone.
Hello and welcome back. We are on our social media. Mel, it has been going off all day, celebrating World Engineers Day. What is coming up on the live feed?
There is so much good stuff still. There's we've started seeing some videos come out, so I'll get to those. We don't have the audio of those videos, but before we get to that, I want to show you what's going on the wall. It's moving so quickly, which is wonderful to see. If we could bring those up now, that would be great. Here we go. Okay. So as you can see, it's moving along, but I wanted to pull these out here. So these are some students that have been spotlighted about why they wanted to get into engineering and such. It allows me to have a positive impact in the medical industry. That is so great. I just love that space of engineering. And this one, I love. My year 12 maths teacher said to me, try engineering. The world needs more female engineers. I know that's something very close to your heart.
Yes, my physics teacher, shout out to Mr. Adamson at All Hallows in Brisbane. He said I should do engineering, and that's why I'm here. The only reason I'm here because I'd never heard of it. So shout out to all those awesome teachers who encourage young people to go into engineering.
That's right. And so Charlotte used to think an engineer was a dude who built bridges. And that she wasn't going to be one. So now she hopes to help other girls realise their potential in many applications of engineering. I think I know a few not-for-profits out there who can definitely help her spread her message there. Joe, I wanted to learn how to create solutions to the current insolvable questions within Australia. Joe, well done. Keep going because you are in definitely the right area here. This one, Uni of New South Wales, Canberra, multi-robot systems. So look at the robots. I just love watching those robot wars and stuff. So I bet those guys do that on the side as well. This is from Marlene, who you've seen. This is a quick little idea of what the our translation and transcription service looks like from iFlyTech. As you can see, 6 languages. It's pretty intense in there, so you definitely need to be watching it on a computer screen. But it's a great way to really experience this, especially when we're coming up to China next. And there will be some content in other languages. So definitely check out that link there. This one, Royal Australian Air Force. I didn't catch the name on this one, but she looks so happy and she's an engineer. So yay for that. This, I love the Department of Industry Science. Thank you so much for doing a post and spotlighting Davidson's engineering and for creating the Davos fencing clip. I have no idea what that is, but it looks like something to do with farming, and I'm sure it's very important. Revolution Farm Fencing. So that's
super cool. I think they were on Shark Tank. It's pretty awesome what they're doing. Yeah, I didn't realize fencing was so hard until I watched the Shark Tank thing, and it's an invention for everything.
Now this one I'm going to do a little call out here, a little personal. I was on Twitter Spaces earlier today. You can see my photo down there. Elizabeth, who some of Felicity and I know a bit. Marlene and I were actually on her Twitter space, and she's got a few going on over on Twitter. So if you want to go over and check that, Engineers Supporting Engineers. It's a great little feed there for Twitter. All right, and I'm going to quickly browse through these because we are nearly at the end of our Australian region. So there's some engineers doing some great work, some from JCE. And then we've got ANCA. They've got a lot of videos out there, a lot of photos out there promoting their engineers, which I love to see. I'm going to quickly show Instagram because they've got some videos playing, RMD Quick Form. They've got look at the difference to how it's progressed over time. So they've got some building structures to life. So thank you, RMD Quick Form, for bringing that up. And Saab Australia, they've done a great post here. Engineers make up 60% of their workforce. So absolutely crucial in cars. So thank you, Saab, for doing a post. If you want to check out your LinkedIn feed, just do that whole LinkedIn hashtag World Engineering Day and see what comes up. There's some really great posts up there of people just doing shout outs for engineers and such. Now, and I'm going to finish up on YouTube. There is a live event going on in Batangas State University. And I haven't caught what they're talking about yet here, but it is definitely something that people, if you're looking for something to do, go and check it out. And that's where we're at right now at the end of our Australian region. So back over to you, Felicity. Thank you.
Thank you so much, Mel. So much happening. So inspiring to see all those proud engineers. Such a great celebration of World Engineering Day. So that concludes the end of our 3 hours in Australia. We're now going to move over to China and do 3 hours in the China region. Lots of exciting things coming your way over the next 3 hours. Exciting to see more hackathon entries that we'll take a look at. And we're now going to cross to our China Hub, which is the China Association for Science and Technology. Let's have a look at what they're up to.